Oh, okay. Alright. Alrighty, alrighty, alrighty. Mesh decomp and BVH. That's what we're doing. That is what we're doing. Alright, the title is a bit what should we call it, misleading. We're not actually going to be doing mesh decomp. We failed at mesh decomp. Okay, it is a bit more complicated than I thought it would be. I'm not gonna lie. I was quickly humbled yesterday. So instead of doing that, what we're gonna do is we're just gonna build a BVH over the triangles themselves. Because that's how most engines do terrain anyway. As far as building a mesh decomp for meshes, I don't know how we're gonna do that, but it's mainly a thing for, destructible terrain or whatever. I don't know. So it's good that we have the beginning of mesh decomp implemented, but it's not nearly good enough, especially for terrain. So most engines apparently just do a BVH over all of the triangles. But I feel like that's what I'm gonna do now, because that seems like probably a good way to go about it. So on our mesh, we have I'm just worried if we get like a massive mesh in, like maybe we want to have each hole has an option to just be just have a BVH inside of it, because right now we just have the BVH stuff on the outside, but the BVH stuff on the outside isn't even. Oh wait, the BVH on the outside is triangle bounding boxes, isn't it? Did I already build this? Hold on. Didn't I already build this? I think I did. Validate child. We go based on the bounding boxes of the triangles. I think we do. No, we go based on the holes. We need to build the same thing, but with triangles, which is going to be exactly the same, pretty much. Hey, what's up, Jack? I think it's gonna be the same thing. But what I'm trying to figure out is, do I want it to be... Right now this is over all the holes. I want it to be over all the triangles. But I'm thinking that I do it over the triangles inside of holes, because we may end up with... if we have a massive fucking mesh, like millions of triangles, then we want to split it up into different chunks. And those different chunks will be the different holes. We'll just split it up into different holes. Now, I hate to just copy code here. I should probably make another file called BVH or something like that. Maybe acceleration. Let's do that. And this is going to keep all of our acceleration structures so that we this is going to make it so that we just don't have everything in this massive fucking file, because as it is, we have everything in this massive fucking file. Right, so that's incremental hole up there, and I'm just gonna go down and copy this over. And this init mesh BVH does it based on the holes. But for now, we're gonna leave that on its own because we don't actually have the ability to do that. But whatever. Am I a senior developer? I don't know if I'm a senior developer. I'm a programmer. I don't really like the term senior developer. It's an interesting term. I think if you're like, I don't know. I think everybody's somewhere in between. Cats. Yeah, so let's try BVH, and then it'll take in a... Dude, I can't fucking type today. That's what we want. Right, each mesh has nodes. And so, unfortunately, we're going to have to bloat the struct a bit on convex hull. We are going to need a... We're going to need whatever is on the other fucking thing. Which I think is BVH node. We need a... We need a vector for BVH nodes and then the leaf indices. Now, do I remember what this exactly does? No. No, I don't. No, I don't. Okay, so leaf indices is another thing. Okay, so yeah, so leaf indices and then... I could really put that into a struct. Because that's never really going to change. For now, let's just leave it. Okay. So going on here, we're just going to copy this in. We have so many errors in the file that... Oh, unknown type name and shit. Okay. Include utilities. Okay, there we go. Okay. What was this? This was the leaf indices. I don't remember how this works. I made this like the other day. Then I immediately forgot about it. But I did make it on stream, so you can see what that looks like. But yeah, it is just a BVH. But now it's going to be over triangles, because that's apparently how we're supposed to do it. Oh, and then the root count is obviously going to be whole faces. We're gonna go based on faces, which are the triangles, right? We will need to fill if it's just a raw mesh coming in and we're not going to do a whole decomposition on it, then we're just gonna need to call a primer function that makes a hole for it and then just puts in all of the triangles. So this is gonna be if that was holes before, yeah. Beginner encoding. Back in Django. Do I think I'll find your job? The job market is quite hard. So, but I do think that if you enjoy programming, then I think that it's a lot easier for you to get better at it. So, as long as you enjoy it, then you should be fine. I think so I think that it's important to do two different versions, one for triangles and one for not triangles, because it's literally just they're two different things. But maybe it's fine. Yeah, I was thinking of a way to do it without copying this massive fucking amount of code. But I'm too stupid to figure it out because they're two different structs. So they're doing the exact same thing though. I'm like pretty sure it's the exact same thing. Okay, so let's go through. So we're gonna cast vec holes faces. Mesh face. I should really just go through and... No, I can't replace hole with because I have to do this, obviously. Whoops. This is annoying. This is really fucking annoying. Oh, I don't have the triangle centroids ready. Well, that's annoying. Fuck. Well, that's really annoying. Because the AI takes some part of front end raw like vibe coding, but I really like coding. Yeah, I'm not somebody that is on the AI kind of train, you know. But yeah, I mean, I like coding personally, and I think that AI definitely takes the fun out of coding, for me at least personally. So am I going to pre-compute the centroids and then sort them as we go down? Because I don't want to have another struct. We can compute them on the fly, by the way. It's just going to be slow to build a BVH if I do that. But I can compute it here. I need to cast the thing though. Uh, I'm from Uzbekistan. That's awesome. I'm from America. I'm I used to live in New York, but now I live like on the southern coast. And honestly, I kind of fucking hate it here. I'm not I'm not the biggest America fan personally, but it's all right. Can't really complain. So I'm just adding all of the things. So points, face, indices 0, 2 points, face, indices 1, 2 points, face, indices 2. And then we just have to centroid equals vec3 scale. With the centroid, we want to do it by 0.3333. And that's how we get the centroid. And then why am I not the biggest America fan? I think America is a total scam. Like, the quality of like life living here isn't as great as they make you believe on, like, the videos you'll see online and how it looks like in the movies and things like that. Like, really, it's kind of very similar here as to the rest of the world. Um, and all of we have so much land and there's nothing in it, right? So if you live in a place like New York or Chicago or like Seattle or something, you'll you won't have to deal with that because you can just like walk around everywhere. Like, you have a walkable city, right? But if you live anywhere else in the country, like where I live, there is no town, right? There is no city. There's no local shops. It's literally just fast food and like malls and just like grocery store, like massive grocery stores and things like that. Like, there's no local shops. There's no like, it's all mass produced. Like, the cinemas are owned by like AMC, and you know everything is just big companies and large parking lots. There's no place to walk around and to meet people and to talk to people. I think it's just an incredibly lonely place to live. Like, when I lived in New York, right? I took the subway to work in Lower Manhattan every day. I worked at a deli, and I would meet people every day. You know, I knew the guys at the coffee shop that I would go to before I got on the L train. You know, I would just walk in, we would talk and stuff like that. I knew the guy at my deli when I would get a sandwich after work. Even though, you know, living in the city definitely has its depressing points, it was unbelievable. You know, like I knew people, and I like felt a sense of not being completely alone in the world. But I think like 99.99% of America is just like that. You know, it is seriously just like very desolate landscapes. You know, and so I find living here to be pretty miserable personally. But yeah, I do miss living in New York. But at some point, I literally couldn't pay for it. You know, so yeah, that is my thing. But you know, I mean, I'm not everybody, so you know, everybody's gonna have their own take. You know, but at least the consensus that I've seen from the people that live in America is that, you know, people typically agree with me that it's pretty miserable, you know. But I'm sure that it's miserable other places too, right? Like it's not like this is like just in America, but I think that the consumerism in terms of America just makes it a lot worse because we just consume all of the trash from like big companies, and then it ends up just making our lives a lot worse. But yeah, that's just the way I think about it. Um, I'm just replacing all of the holes with faces, right? God, this is kind of a pain in the ass. If AABBs intersect. Alright, this is where I go through and then I... Alright, this is at the end. Where I check if they intersect. The worst thing is that I'd have to build... Yeah, we're not gonna do this. We're not gonna go based on AABB. We're just gonna check if the centroid is within the AABB. Do I have a function that does that? Let's see. No, I don't think I do. Alright, yeah, let's just do it here. Do I take in a pointer to the ABB? I think I do. You like, how can I get there like Mexico? I know price is really high. Yeah, I mean, it's not really just like, I feel like America would be a fine place to live if like you are like kind of like upper middle class to upper class sort of thing, where like you can buy whatever you want at the grocery store sort of thing. But if you're not in that, then it's just, you know, like America's kind of fucked because, like, for example, Mike Lung just straight up collapsed a while ago, and it's like now it's like we're just like insanely in debt, you know, like it's like it's not like I had any control over it. It just like randomly happened, and now it's just like, you know, like you have to pay for that shit. Like it's like ridiculous how much you have to pay. It's like I was in the hospital for like 3 days and it was like $9,000. Like, isn't that fucking stupid? Like, what? Like, is that fucking ridiculous? Like, that's not right. Like, that's ridiculous. Yeah. It's just ridiculous. It's really stupid. America's really fucking stupid sometimes. I'm just gonna calculate the centroid again because I'm lazy. We can put it in a thing later, but for now I'm just gonna keep recomputing it. What's the ABB? Parent ABB. Okay. Wait, hold on a second. I think I'm just realizing something. I'm scared to look at what's above us. I think we have more code to write. Oh no. Mexico's really best option. Yeah. Yeah. Apparently. But then But then again, you do get killed, possibly. What is validate child? I don't even call that function, do I? No, I don't. Okay. So is that it? So we need to init try BVH for a hole. Okay. So instead of doing mesh decomposition and incremental hole, what we can try to do instead is just put into, let's init vector mesh holes. Let's initialize it. And let's just get a convex. I need to set up a infrastructure so this happens automatically, but for now, let's just do this. Let's just expand. I've heard American people don't like Mexican people. That's actually, I think that this is just like what you hear overseas. Like, we have a giant, like the middle of America is like a giant, like kind of racist population. Like, that's just the only way to describe it. But like, the people that are like on the coast, like me, for example, are just like like we just like don't understand the rest of them. You know what I mean? So it's very strange because like America is divided into these two halves of people, and it's just like, you know, because it's just honestly it's ridiculous. Like, I don't know. Like the whole thing. So the way I think of it, like in America, we have a lot of unemployment right now, and we have for a while, especially in the sectors where like the poor racist people work, like for example, in, you know, construction and like things like that. And so what they do is they like blame, like, you know, immigrants for taking their jobs just because that's what they hear on the news. But like, it's just like, it's just, that's not like the rest of America, you know. It's just a shame that we have to like share our country with them, to be honest. Like, it's kind of ridiculous, you know. It is just kind of stupid. Anyway, so to get this whole save the stream, you think that Trump is gonna take down the stream because I'm shit talking the U.S., the racist people? No, we have free speech here. Don't worry. Yeah. It's true though, we do have free speech here, so that's good. I mean, it's not like the government is gonna come on the stream and then, you know, fucking come after me, you know? You know what, I should make a thing that is, yeah, let's malloc size of vec3 times Oh, this is faces. Wait, but I'm starting to realize that this is going to be complicated. You know what I should make? I should make I should make a utility that copies a vector into another one, like buffer wise. Okay, how do we do this? Okay, so first thing we have to do, so copy A into B. What we have to do first is if B dot, oh wait, hold on, this has to be pointers. If B buffer I don't know why I'm copying the whole struct on its own, to be honest. What I should do is just this. Weirdly enough, I think that this is in string.h. It always confuses me why memcopy is in string.h. I don't know why that is. Probably somebody smarter than me probably knows. But that's funny. Always funny to me. So what we want to do is we want to use this new copy vector function to copy from mesh vertices into the whole vertices. And then we want to copy the faces as well. Wait, is faces called tries? Okay, it is. Alright. And now let's get this function in there and it try BVH. Let's include it. Acceleration.h. And let us try to init try BVH. It's getting mad at me. Call to undeclared function init try BVH. Did I do this backwards? I did. Okay. So now we have that. I have no clue how we're going to render this to the screen and debug it, but let's try and figure it out. So right now what we're doing is this triangle sort of thing to check out the holes themselves. Let's not really do this anymore, obviously. Hold on, let's try and figure out how to do it. We can go through all the faces, but that's not what we want. What we want to do is we want to recurse through the nodes in the thing. So let's just go. Also, this -10 is weird here. Let's go through all the holes count, even though there should only be one. Wow, no one in the stream today. It's just me on my lonesome having to carry everything. Okay. So we will go through nodes. I think it's nodes. I think it's nodes. And then we will go, if we need to get the BVH node, we want to cast vec. Oh wait, no, you have to do this in here, obviously. You live alone? No, I don't. Your age? My age is 24, 25. I can't remember. I used to live alone, but I find it kind of hard, yeah. Or no, I never lived alone. I used to have roommates. So, yeah. Yeah, I've never had my own place, which seems crazy, but yeah. Not once. I only ever had roommates. There's no way to like live alone, I feel like, unless you have a really good job. Really? Forget my age? Yeah. I mean, I kind of hate the fact that I'm getting, past my early 20s. It's like, it just kind of sucks. I don't know. I had this, my ex-girlfriend's aunt once was having this conversation with me about like age and stuff, and like how she's like, man, it doesn't get good till your 30s. It's like, that is some bullshit. That is some absolute bullshit. What are you talking about? What are you talking about? That's not true. That's just literally a lie. Like, am I married? No, I'm not married. I am not married. No, I live with my family and my sister. Yeah. I doubt I'm ever gonna get married, to be honest. It's just like, I have like, mental issues and stuff, so it kind of is better for me to not be married, so kind of sucks, but that is what it is. Okay, so render, do I have render ABB? That's what we were doing. Node ABB. I don't remember what VBO we were doing it. I think that the wireframe VBO with an offset of 0. I have no clue what this is gonna do. Whoops. Alright, let's try it. We just wrote a lot of code, or like just, you know, we just rewrote a lot of code. Implicit declaration of print AABB. Undefined reference to init try BVH. Oh yeah, you're so right actually. Let's go into the make file and change this. I'm still learning English around 1 year. Your English is good. If you're not using like, you know, Google Translate at all, that your English is really good. Like I can, you know, totally understand it completely. I suck at learning other languages, like really bad, like so bad. Let me just see. I never got past, like, in college, I never got past, like, French 2 or something. Okay, so we're dying in here. Let's actually see if this copy vector thing is giving us problems. Yeah, it is. Okay. Let's try whole vertices dot buffer equals null. I may have to prime it. Why using mid-GW? Is there any reason why not using MSVC? I think so. Mid-GW is just, at least in my experience, is just way more versatile for when you aren't doing like a proper build system with like CMake and like Visual Studio. Like if you're doing what I'm doing, which is like kind of just like janky GCC shit, then it's like, at least you know, in my experience, I haven't really used MSVC very much at all. So that is the truth. I usually use Linux, you know. But M76, I have no clue where that is coming from, but I'm guessing since we now copy the vectors, then it's fine. I'm gonna assume that when we're rendering is when we're dying. So let's just get rid of the, oh, we have all of this shit still. I forgot to comment that out. What? Oh, it's extraneous closing brace. Oh yeah, I didn't get rid of that. Okay, so yeah, it is probably this. Yeah, oh no. Okay. Unless it's that. I'm just trying to get it so that we don't crash really quick. Okay, we have to really. The weird thing is that, oh no, we don't. We're dying in here for sure. Okay. So let's do some debug printouts for checking out what's going on here. Let's just see how many nodes we've entered. Just to see if we're getting somewhere or we're dying immediately. Okay, we're dying immediately. Like, it's not even... Okay. That's fair. That's fair. Hold on a second. I think I may know what's going on here. This mesh vertices might be a different type. Let's actually check this. Our mesh vertices, when we load in our meshes, are points. Aha. Okay, so we do have to manually convert it. Okay, so that's what's happening. So we can't just copy the buffer. We actually have to go through all of the vertices and then convert them to... We have to convert them to vec3. Are you using a debugger like rad? No, I mean, I use GDB sometimes, but like for here, you know what, I could have just like GDB'd it and probably figured it out, but sometimes I'm just lazy and it's faster to just, you know, just cheat and just printf. Why don't I use Linux? I'm using Windows right now because this computer is a Surface Book 2, and the graphics card in it needs specific drivers that only Windows has for the NVIDIA card, or else it pretty much doesn't work. But yeah, the computer just runs better on Windows just because it's literally like a Windows machine, you know? You feel me? So this is point mesh vertices with a type of point. We're gonna cast this, and then we want to vec3 pointer. We need to init vector. You know, this is like such a verbose kind of memory library that I'm building for this engine that it's like a lot of code you have to write. It's like, even though it's like versatile and abstracted, it's like, it is kind of annoying. Like that I will admit, because you do have a lot of the pause. Okay, and now all of that is correct. Okay, we're still dying. We're still dying. And why would that be happening? Is mesh tries mesh face? It should be. It is. Alright, now I am going to use GDB, because now I don't know where we're dying. Okay, in the centroid calc. So our points are not... Our points is whole vertices Faces whole BVH indices I. So I'm gonna guess that this is the problem, actually. Let's look at the reference code that we had before. So mesh BVH indices I went into whole, which is the equivalent in this new code. And the primer for that was we set it to holes count. We set BVH indices I equals I. You started cybersecurity, like IP address or MAC address or attack to the Wi-Fi. I need your advice. Which job to have their future? I don't really know anything about cybersecurity. I've seen some videos about it online that seem pretty interesting. But I personally don't know anything about it. I think it's probably a good field to get a job in, though. That's for sure. The question is it the faces that's the problem or the points? All right, let's just print it out. Dude, I'm like tweaking out today. What else do I need? Oh yeah, I need I. That's what I need. I want to see I and I'm tweaking right now. I just can't type. How much experience? I've been doing it since I was like 17. Just off and on. Okay, so that's what I was worried about. Oh wait, we might just be going into a different comparison here, so that doesn't actually prove anything at all now. So we hit 27, and they are exactly the same. Okay. So let's see, let's see whole faces dot count, because that's what's going to matter, right? Is are we going out of bounds with that, or are we going out of bounds with the points? Okay, so 76. So we aren't going out of bounds there. We're definitely going out of bounds with the points. So that makes me feel like this is whole vertices dot count. And if that's the case, then I don't know. Just go Linux. What is ATP? I don't know what ATP is either, to be honest. I'm so confused. Here's what I'm gonna do. I'm going to manually copy the vectors because I don't trust this function that I just wrote. Oh, also, the initial whole... Wait a minute. Whole AABB equals mesh AABB. I never did that, which also kind of matters. Whoops. Okay, let's try that. Now there's no way that there's an issue with the vector copying. Okay, that's what we want to see. Okay. How many nodes did we enter? Only 63. Which does seem pretty small, I'm not gonna lie. So I'm not sure what it was, if it was the bounding box or what. But let's actually check this now. If we don't set up an AABB... Okay, so it was copying it. Okay, so we set up the AABB and now we hopefully can render this. Hopefully. Okay, we didn't render anything. Well, that sucks. I guess I can print out the AABB. Do I have a function that does this? No. I'm just checking if that's correct. That code right there. Print try, print triangle, print vec3. Kind of want to just print an AABB, but that just kind of sucks. Yeah, let's just print vec3 for the node extents and node center. That will tell us. Okay, so we have center and extents. It just isn't rendering. Okay. These are legal extents, right? I mean, they're pretty massive, but we should be seeing something. What could be causing it? I mean, if we have the nodes themselves, then we should just be able to render it. I mean, maybe it's possible that... Yeah, I mean, not being able to see anything is kind of strange. Maybe we have too many nodes that it's breaking or something. Maybe we just do the first 10 nodes. It is a lot. Okay, we can hard code it, I guess. Maybe this is shit is just simply not working. And I should just do the points themselves. How about this? Instead of all of this, let's just do... Actually, yeah. So let's just do the... Let's just return corners. Oh. Let's just do the corners, and then instead of doing this, let's just do GL points, and then call point size 10, and then just do 8. Alright, so let's just see if we can do the points. I'm so confused. If I render the ABB for the whole thing, right? Instead of the node, I go for M. Does something show up? It seemed like it did for a second. Am I going crazy here or what? Oh, also we have a memory leak. I feel like I'm going fucking nuts right now. It's like disappearing. Like it renders it for a second and then it disappears. What the fuck am I doing? Dude, this is ridiculous. Okay, well, at least this still works. Oh my god, I think I'm realizing something. Okay, I want to apologize. I want to apologize sincerely. That the reason why I wasn't drawing everything was because it was drawing it black. Okay. Well, this is still a fucking complete disaster. But that's alright. At least we're drawing now. Okay. Let's just start from scratch with a clean scratch slate here. Okay. So we have a few problems. We do have a few problems. If node left equals null and node right equals null, meaning that it's a leaf, we're only going to render the leaves and see if that does anything. Okay, no, it doesn't do anything. Can I do line loop? No. Yeah, there's some bad memory that's getting touched somewhere. Just try to print them out. Let's see if there's anything. The weird thing is that there's nothing. There's no like ridiculously high values that would break things. So that's why it's confusing to me why. Oh, it's probably... Oh, maybe not. Hold on. No. Oh, fuck. My bad. I guess when I undid it, didn't undo that. Okay, so this seems reasonable. Hold on, let me get rid of this so that we stop lagging. And also, let's draw the original triangles for it. Okay. Okay, so we have reached the point where we can actually look at what we did here. Surprised that there's not a lot over here. I don't really know what it's supposed to look like necessarily, but we are doing something. Yeah, I mean, I don't think it's necessarily correct. I only exit out if left count equals 0. I think I tried this and then we got some like weird shit going on. Like the interesting thing is here, where obviously if you split this into left and right, then it's going to change. But that doesn't happen. Isn't it left count equals 0 or right count equals 0? No. I mean, it's splitting it the exact same way every time. Like, exact. Hmm. And how many nodes are we getting? We don't get a lot. Ah. It's not that. I think I'm finding the centroid right? Yeah, I am. No, yeah, I mean, the left count makes sense. Like, this one's bizarre. Like over here. It's weird. Like, what is that? Why would that happen? Wouldn't it split down the middle here? So you made lots of progress? Yeah, I'm working on right now. We've got two different sorts of mesh decomposition things going on. Right now, I'm working on the one that's just a raw BVH over the triangles. The other one I've kind of given up on, which is, cutting the meshes into convex planes, which honestly didn't go very well, to be 100% honest. Oh, you know what it might be? Oh, actually, no. Oh, yeah. Hold on. This is everything that isn't a leaf. But then once again, there's nothing over here. There's nothing over here. I wanna try something. I wanna pass a where is it? I wanna pass a uniform to this based on how far it is inside of the array. It's gonna be J divided by whole BVH nodes dot count. Just to see, is that one... Oh, I need to... Just to see if that one's the... So we have green ones over here, pink ones over there. I think the pink ones are the ones that are later on. Did I manage with the slipping? Yeah. Yeah, that was just a collision code that I didn't do correctly. Parent left equals left, right equals right. And then we pass this down. I have no clue how to figure out what is why that last one isn't splitting. How am I gonna do that? How am I going to do that? Here's something. I could compute the ABB over the also isn't first leaf indices that count -1? Or maybe not. Let's try it. I mean, this actually won't change anything because this isn't tied to the bounding boxes. Right now what I'm trying to do is I'm trying to figure out why this one isn't splitting in the BVH. It's like it should split down the middle and go into left and right, but it isn't. And I have no clue how to debug it. I need to figure out which index that one is so that we can just like print it out and figure it out. So what I'm gonna do is just do this until we figure out which one it is. Okay, so it's ones that are really close to the end. So I'm just gonna start by trying to get down to the exact one that it is. I think that it's like, yeah, so this is what I'm saying. It's the last one. It's the last one that's added to the array. That's what we have to go off of. It's the very last one. Why would the very last one be weird? We should try and figure out the axis that it splits on, because then we could probably debug print out why it's not splitting on that axis. But it should at least attempt to split on that longest axis, whatever that is, and then it fails. You know what? I have an idea. What if instead of doing centroid, we go based on... No, you have to go based on centroid. What I'm starting to realize is that basically everything is a flat array that we're sorting as we go along. And so the BVH at the end probably doesn't have all of these triangles in it. It probably only has a little bit. And we can actually prove that by, instead of printing out the AABB, by printing out the actual points themselves that are within it. But I'm guessing that the triangle that it has left is like literally on the edge. And so it just has one triangle in it rather than all of the triangles in that bounding box. Maybe this is just how a BVH is supposed to work, though. Like if I like show all of the triangles, then it's 100% just gonna work. It's just kind of a pain in the ass to do that, but I can do that real quick. Yeah, is it node count? I think so. And then node count goes into the BVH indices. Is that correct? Or is it the leaf indices? I think it's the leaf indices. It's whatever we push to at the end. It's leaf indices. And leaf indices gives us leaf indices gets us the shit that goes into the face. The shit that goes into the face. But is that a size T or a... That's what I need to figure out. Size T, yeah. Wait, hold on a second. It's not even a cast vec. It's no, it is. Okay. Now we need the triangles array, which we do have here. And we just need to print it out, free the buffer, and then draw the triangles to the screen. And then stop drawing the entire mesh. And let's see if that works. See, this is what I was saying. Oh wait, why? Oh, I didn't mean to render the. We can just do it to this. Okay, no, we aren't seeing anything. Why don't we see anything? Oh, we do have to use, because it's a different VAO layout. Why is this not? Oh, because we don't have a color. See, one triangle. I don't know why it's bugging out, but yeah, it's one triangle. Why are you bugging out? Face indices into points. Face normal. Oh. This is. It is main vertex. Wait, so why isn't it? Oh, it's because I had that. Okay. Okay, like, work with me here. Yeah, the offset wasn't right. Yeah, I don't know what the other shit that's happening is. We could try all of the nodes. Yeah, obviously I'm doing something wrong here, but I'm not sure what it is. Is the points good? Face is good. Face is leaf indices K. Oh, it's not K. It's not K. It's node it's node first index plus K, right? No? I'm so fucking confused. Why doesn't this work? Whole BVH indices goes into mesh face. So why? This is happening without this now. No. Oh, hold on a second. Oh no, yeah, I never inflated. I just go back to the parent. Oh wait, but I expand it here. I expand it there. So there are just bad nodes. I could have it return a boolean that explains if we subdivided. So if I return false, okay, well, that didn't work either. Why did that not work? Oh, because no, but this only returns if it's in the direct child. That only returns if it's in the direct child. Ah, shit. Alright, well that was some infinite recursion right there. Yeah, I mean, I'm not smart enough to do that, I guess. I guess I'm not smart enough. And we just crashed there. Yeah, I don't really understand. Maybe I shouldn't be going through BVH indices. Oh wait, yeah, I shouldn't be going through BVH indices. I'm just going through the entire faces count. I guess it's the same thing. Yeah, it probably is the same thing. I don't really understand why we have these flashing triangles. It's kind of weird. And I copy them correctly, right? I'm just going to try to mem copy it instead of... I don't think that's going to do anything, but yeah. Hey, what's up, Lily? I tried your theme. I didn't like it. I'm sorry. Let's try something. Wait, hold on a second. Yeah. I never choose if it's left or right that's going through. I guess it's J. Can you fuck off, please? Just that instead? I'm patching Xlibur is fake. You're going to open a PR? Holy shit. That's big. That is big. I think I might be shit at programming. I don't know. Someone opened an issue on the Xlibur port. I don't know Nix that well. Yeah, you said that. You said that. There we go. Okay, there we don't go. Dude, like, what the fuck are we talking about, bro? What are we talking about? Take the first index. Oh. Oh, first is... Oh, wait, no. Oh, I don't go found into C++. That's the problem. That would be the problem. Like any swear word. I'm not sure. They've gotten before quite a bit. I don't think you can go like ham. Yeah, that segfault is kind of crazy. Why are we missing so many? That's my question. That would be my question. Why are we missing so many triangles, bro? Node first index plus K. That is correct, right? Leaf indices that count. The first index gets to put the first. That is correct. What else is in parent? Parent, first index left, right? I'm so confused. Right now what I'm trying to build is I'm trying to build the BVH over all the triangles, and I'm failing. And I don't know exactly why I'm failing. Well, we never said the root. But we give the root down. Yo, what's up, Anna? How do we open up a pull request on Codeberg? I have no clue. I don't know what that is. Would it be a smart idea to keep the KD tree on the CPU side, and in the future LBVH for GPU? Yeah, I mean, if you're gonna do the both of them, like maybe it's useful for some things to keep it on the CPU. Then again, I don't know. Maybe don't listen to me because my BVH is fucked. So that blows. That really does blow right now. And I don't know how to debug it. Oh wait, hold on a second. If I do, oh, I'm supposed to be just doing I here if I want to do this. I'm supposed to not be referencing BVH indices there. Holy fucking shit. That was the bug. Let's go. Okay, I take back what I said about, being, bad or whatever. I was being really down on myself and beating myself up because I couldn't get this to work. And now, you know what? I'm just going to say it. I think I'm the best programmer alive. Like, giving good insight? Okay. Well, thank you. I appreciate that. Okay, so back to what I was doing beforehand, which is not this. Back to doing what I was doing beforehand. I want to see how the bounding boxes are. See, like, look at this business that we got going on. Why is this one not splitting, bro? Bro, it's not splitting. And it's the problem is it's the last one. It's always the last bounding box that doesn't split. It's fucking cooked. It's fucking fried. It's chopped. It's over. It's the last one that doesn't split. You can watch it. You can watch it like this. So if we set whole BVH nodes dot count -1, it's the last one. The last one doesn't split. The fuck, bro? It's kind of tilting. Yeah, it's easier to have a CPU physics engine. Yeah. Yeah. Definitely. I think for physics stuff, for sure, it's better on the CPU. But like for like, lighting, like they were talking about in the paper or whatever, I think like that, those things or whatever you want. I don't know what they're talking about is beyond the scope of my little stupid little brain. So we sort the BVH indices. Somewhere, somehow, we put shit into the wrong place. So getting rid of this, by the way, this causes infinite recursion, I'm pretty sure. Yeah. You don't want to do that. You don't want to do that. I also had this. This is how I had it originally. Because that's what I saw somewhere. But this doesn't do it either. Oh, man. Let's only render the triangles that are in there just to see if it's also a triangles issue. Open a PR, wish you luck. I'm wishing you luck. You're gonna do fine. Okay, so why are we dying? This is a mess, man. I need to clean this shit up. I need to really clean this shit up. Okay, why did we die? Fucking Christ. Oh, probably because of that. No? Why is this not working all of a sudden? Fucking what? Hey, what's up, Ash? What the fuck is the problem? Oh. No, don't break point. Realic vector expand in the subdivide. Okay. And why? Oh, I guess it's this, huh? You're the problem? I wish it was that easy. Okay, so let's be fucking serious here for a second. We're looking at all the triangles that are in that one. Okay. Let's ignore that for now. Okay, so bro, you gotta split this shit down the middle. Like, let's be honest here. That's what you gotta do. You gotta split this shit down the middle. So why are we not splitting it down the middle? The whole point we did this was to check for that. And it showed us that we don't know what we're doing. So basically what this is this is where we are in the BVH array, right? And we just want to iterate through, and those are the ones that we push onto the final array. The problem with this is that it doesn't fucking work, which is like a tragedy. Like, what the fuck are we talking about, bro? Like, let's be fucking real here for a second. I should buy a cat. Those are elbows. I can see the elbows. It kind of looks like two birds kissing. That's what I see. Did I cast BVH indices as an int anywhere? These are supposed to be size T's, aren't they? They are. I mean, I don't think that that's ever going to be a problem. But, I mean, when in Rome? Bro, come on now. I do have a cat, actually. I doubt that these not being size T's are, you know, I genuinely, you know, heavily doubt that's the problem. Okay, hold on. So if we subdivide it in the left... Hold on a second. Hold on a second. Yeah. I have it. If else, we need to return false here. Because we don't want to divide the right. Okay. No, this needs to be true. So that we don't keep dividing it. Shit. Okay, well that broke things, but let's just try to go from 0, I guess. And let's see that this time. Okay, well this is a fucking mess now. The idea, right, is that if we, in the child, decide that this is a leaf, and then we just exit up, and it was a left node, then we obviously... Oh no, we do want to check the right node. Wait, I just realized something really stupid. I think I'm really stupid. Hold on, I'm really dumb. I'm really stupid. Hold on. Hold on a second. Why? Wait, hold on a second. Wait, what do I pass in as the parent? No, I pass in left. So I'm not crazy. No, I'm not crazy. Why do I never do block comments? Because it's so much faster to do this in Helix. Like block comments are like, it's space shift C. It's like so incredibly like when I go through and I actually document stuff, then like sure, I do that, but yeah, no, never mind. I am kind of doing it correctly. Because I need to write everything into parent, because parent is left. Parent is this left. So that makes sense. The reason why it's the last bounding box that's not getting everything is because it gets to the end of the array. I think it gets to the end of the array. But simply put, it has the triangles in it. It's just not partitioned the way I want it to be partitioned. You know what I could do? I could do, if it splits once and nothing splits, then it can check like another split. But at that point, there's like a lot of recursion going on. You feel me? But we need to get to less triangles, because I don't want to have to test GJK against all of those triangles. That sounds awful. That sounds awful. So this can't be the ending conditional, I think, is what I'm deciding. It can't be. Maybe we do... If left count and right count equals 0, then we still can recurse downwards, right? Into left and right. How do we exit out? We could exit out only when, like, the total triangles in left count is less than a certain amount of, like, 3 or something. If there was an existent parent, erase the child. Yeah, I don't really document until I finish things. My theme is WCAG AA compliant. It's Picosaurus. You're talking about the one that I tried? I don't have anything on this computer. Yeah, I don't use anything other than Helix. Okay, so if left count is 0 or right child count equals 0, that means that we didn't do any splittage when we split the bounding box. Okay, so we do this. And we're gonna create some infinite recursion here, but let's not worry about that. So if there wasn't any splittage and hold on. Wait, this isn't gonna work. Okay, let's just do a different thing here. Okay, so we can split if both sides have less than 3 triangles and one side has 0 triangles. There we go. Ah, shit. You see, what is that? Why are we... What is that? Critical error detector. Realloc. In subdivide tribe BVH. Okay. And why is that? Fuck. I'm gonna guess that it's this vector expand. Maybe me making these size T's was a problem. Wait, hold on a second. I do init it to size T. Okay. $487. I may have like infinite recursion somewhere here. How many frame buffers do I have on a render loop on average? Depends. Like on this, I'm gonna have like 1, but like on my old projects, like for example, the other game engine, I had like quite a few. That was bouncing between like probably 4, 5, something like that. I tried to reuse them as much as possible, but yeah, sometimes you need a bunch. Wait, so how are we dying when I go BVH knows 1? It says no memory. Realloc. Have I seen your rice? I have not seen your rice. Why is Realloc getting me? I don't free this. I don't free it anywhere. I'm gonna guess that it has to do with somehow this causing like some infinite recursion. No. I never have a problem with vector expand. I never have a problem with it. And I initialize it to the correct size. Now, if I initialize it to that much, then it's going to count to that much. Or maybe not. I forget what init. Do I use wind blows? I'm a Linux guy, but it's necessary for me to do so. So we're somehow running out of... Am I stupid? Fuck off. Why is my vector implementation bad? The capacity should always be bigger than the current capacity. I guess I have to print out everything. I have no clue. Yeah, today is not going well. Today is not going well. Don't you want a translation layer? You know, I hate DirectX, and that's why I'm on OpenGL. Cap 6, count 5. 5 plus 1 equals 6. Goes through. Somewhere we're referencing the wrong pointer. But I don't reference it anywhere else. Yeah, I don't reference it anywhere else. Apparently they don't have bindless textures. Well, that's DirectX 11. I'm sure that they have it in something newer now. I've never had a problem with this before. I could just set it to a large value and just move on with my life. But Yeah, I'm not sure. I'll have to look into it later. I'm not gonna really worry about it right now. I have no clue why that's happening. Free heat block modified after it was freed. Yeah, that's what I was wondering. But I don't have anything that frees. Unless I'm fucking blind. But for now, what I'm literally just going to do is just get rid of this. The only thing that I do is this. I don't free anything when it comes to that. Oh yeah, I need to do this. I should say I mean, is it possible that Malik is failing? Maybe. Heat modified after it was freed. But I don't free anything. You're being funny. You're being funny. You also said Vulcan didn't have very good. Open GL the Bindless God. I mean, I don't even use bindless textures. Maybe it is the Bindless God, for all I know. I don't know how good bindless textures are. But I guess that they're pretty bomb, huh? Okay, I'm gonna move on with my life. I don't know what the fuck the problem is here. Oh. No, but this is BVH indices, not BVH nodes. Alright, whatever. I'm just gonna set this to something massive and then move on. Yeah, and now what is this seg fault? Render. And it doesn't tell me where it's from in render. Oh, it's great. Great, thanks. Okay. Let's try to figure it out. Texture arrays with texture handles? Yeah, I mean, I use texture arrays. I use texture arrays. I would guess that it's this and not the nodes themselves. If it's the nodes themselves, then we're gonna have a problem. Okay, so we check node left and node right, and so I guess it's leaf indices. Or wait, do we have leaf indices? Is that the problem? Or are we just storing... We're storing I. Oh. Oh no, but you still need this. Wait, so yeah, so what is the seg fault then? GDB isn't telling me anything. Do I free it? I do free the buffer. And it looks like the picture is fine, so I'm gonna lose my fucking mind, man. I wonder if it's a problem somehow with my vector implementation or something. Like maybe I don't know. Like what the fuck is happening? I think there's some heap corruption happening, but I don't know, like, I didn't change anything. I didn't change fucking anything. I mean, I'm just gonna go back to, like, what I had before, I guess, like... If it has something to do with me casting insta-sized T's or something... then I'm gonna be pissed off. That's the only thing I changed was turning things to size T. Trace breakpoint trap. Dude, I don't know. I'm just gonna fucking undo everything, I guess. Like, dude. I hate it when I go to GDB and then it literally just tells me fucking nothing. It goes to white mode, it's like a flashbang, yeah. Yes, it is. And now what does it say? Like, the fuck? Wait a second, I think I just realized something. Wait, no, I guess not. Dude, I have no clue what's going on. Is it that? No. I introduced some insane keep corruption somewhere, and now there's like no way for me to figure it out. Oh wait, hold on. Let me get rid of this. No. And what is it telling me now? Oh, I mean, this is fucking stupid. This is fucking getting to the point where it's stupid. I'm just gonna make clean. I don't know if that will do anything, but did the neighbors ever find their dog? I have no clue. They stopped yelling though, so that happened. It happens after this. It happens during render. It happens during render. Oh, maybe it's me setting that to something massive. I don't know. Are you fucking kidding me? Oh, I'm pissed. Well, I mean, what did we learn? Really nothing, to be honest. Just that I'm kind of stupid when I get stuck, and therefore we now have to reprogram a lot of stuff. So I gotta lock in to do that now. I don't know, I can't code today. Okay, let's see this. So can we go back to fucking rendering? I set that to a large number to initialize that to something large, just so that, you know, we wouldn't run out of space or something. But okay, so now we're back to this, which is fine. Okay. Yeah, I'm just kind of bummed out because my method of mesh decomposition that I was trying earlier just isn't working. So that kind of got me in a bad mood, to be honest. Filling extension of the BVH prims on the leaf. Yeah, I wonder how much that space that would take. Okay, so we've brought together the full thing now, And now let's test the AABBs. Okay, there we go. There we go. There we go. So a lot, a bit more. A bit more, sections in the thing. I think we can render both. I just have to bind the other program later. I just want to see what it looks like together. See, this whole thing was one before, and now we've split it off into a few extra ones. So yeah. Now something that I want to test is I want to see if we can only check that one. Seriously slow? Yeah, it is. It is. Well, I mean, it's good for like doing like collisions and resolutions, I think, and like ray casting like bullets and stuff like that. Okay, so that's the new last one, but that doesn't actually show us what the final ones are like. Yeah, so now it's split it up into a few different ones. But the problem with that is that we had to go at the end based on not the BVH indices, but actually the indices themselves, which is not good because the BVH indices are supposed to be somewhat somewhat truth, like a basis of truth. Because if all of the BVH indices don't actually match 1-to-1, then something's probably off somewhere. Yeah, that is a really large amount, though. That is a really incredible amount. If you put it to 1, which is one triangle, how long does it take? Oh, I did make clean by accident. I'm just curious. God, this compilation takes forever. Holy moly. Yeah, it got mad at me there. And we're crashing again. See, this is what I'm really concerned about. Critical error detected. Trace breakpoint trap. And vector expand. There is something with the yeah, if you need help with the Morton code stuff, I can definitely help. So what I think is happening is we have a vector that we expand. We get a pointer to that new vector. But then we reference it. Oh, hold on a second. Parent left isn't parent left because this is a new vector. Aha. 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 And this is why you run with indices and not pointers. Okay, this is why you do indices and not pointers. Everybody, it's because of this problem. This very problem. I was so stupid. Okay, so here's what happens. We have a parent, a pointer to a parent that we get before we go into this. And then in here, we obviously realloc the vector. And then over here, this parent is no longer a valid pointer, right? Fuck. Well, how do we do this? We could just switch to indices. I think there's like no reason to have the non-ABB. Yeah, it's just so much faster. It's just so much faster. Okay, now I've figured out the bug. It did take me a while to figure it out because I don't know why this code was like this for forever, by the way. So, maybe we don't actually need this and it works fine. And it was just this stupid bug. Okay, let's figure it out. Yeah, we need indices. We need indices because there's no way to get the new parent pointer after we realloc. There's actually a zero way to do that. There's a zero way to do that without indices. So we have to do indices, by the way. Which is fine. There's no problem with indices. I'm sorry that it took me so long to figure that out. I was not thinking about it the proper way. Okay, so let's do it. Where the fuck is BVH node in this file? Okay, here it is. So instead of pointers for left and right, we have to go int left, int right, and int parent. That's unfortunate because I had like a really nice, consolidated simple system with the pointers. So you really do hate to see it. But that's all right. I love the pointers rather than the indices. It's just how I always do it. But in this case, with the vectors, because so if this line, by the way, if this line could go up here, then it would be so free. It would be so free. But the thing comes 2 lines late. That's the problem. So just because of that little tiny thing, we do have to do indices. You hate to see it though, you really do. I'm not a big indices guy. But that's alright. Also, it sucks because now we have to do this janky thing, whole BVH nodes.count -1. Ooh, nasty. Nasty. But that's alright. If we ever multi-thread this, then we're completely fucking screwed. But that's alright. That is alright. Okay. I think that's actually it. And then the left parent, I don't give a fuck enough to do the parent indices because I'm gonna actually have to write code for that, so I'm not gonna do that right now because it is not useful. So we're just gonna go change that, and it was that simple. Hi back. Oh my gosh, what is that? What is that? What is that? Okay, we've got all these old functions that we aren't gonna worry about fucking fixing right now because those. So basically, we have right now we have a BVH that goes over triangles, and then we have another one that goes over the holes themselves. So we've got a BVH on top of a BVH. Beautiful. Music to my ears. Fantastic. Now I'm not really sure why this one, why some of them split like a lot. Like some of them split kind of nasty, but that's alright. Will you like my theme if you make it a like mode? The problem with it... So the problem with it is that there's just not enough contrast. Like the dark stuff, I just can't see. Do I instant my AABB debug render? No. No, it's all just raw. Because I'm too lazy to make the... I will eventually, like I did in the old engine, but right now it's like a bit of a pain in the ass to do. I don't have that many anyway, so it's like not ridiculous. Every single color? No, it's not enough though. Like reading this can you read this comment? It's just not possible. It's literally not possible. It's literally not possible. Like if you go to my theme, you can read the comment like so easy. You feel me? You feel me with that? And this is the theme that everybody hates, but you can read it. You know what I mean? You feel me? I've been fucking with the flat white though. Okay, so now if I get rid of can split, how does it look with the fixed indices? See, like this one is still a bit problematic, bro. This shit is problematic, bro. I think it's because it splits somehow and then it doesn't find a split like It's obviously because of this stuff. Hold on a second. We should move all of this back to size T. Like I had it before. Swap size T might be a problem. Wait, what? The fuck did I just write? The fuck did I write, bro? Wait, how ill am I? Wait, what? What? Oh, it's because I was... Oh. Well, that was wrong the whole time. Okay, well. I'm glad that I found that, though. I don't know. I think I wrote that function so fucking fast and then didn't think about it until now. And now I get it. now I get why we weren't splitting. We weren't splitting because we weren't moving the indices along. What's weird though is down here we got like a lot of business going on. Business. And we do have a seg fault. Okay, critical error detected. Okay, we have a critical error detected still. Oh, wait a second. Wait a second. Wait, no. Because we used left to go down here. How could I improve my theme? I feel like we gotta improve the readability. I'm a guy who doesn't like a lot of syntax highlighting, so I get it. I do get it. The thing is, I think it's just this is too dark. The operators are too dark. Whatever these are called is too dark, and the comments are too dark. It's just too dark. But I fuck with the vision. I also think that the blue tint on the functions is just a bit too cyan for me. Kind of like just a tiny bit of a deeper blue sort of thing going on. Throw 4 million into your debug renderer. Yeah, I don't think it's ready for 4 billion tries. I just don't think that it's ready for that. Personally. I could either improve or just use yours. I don't know. I think this is just an underrated theme. It's also the chess engine video theme. So it's just like all around it's just one of the goats, you know. So the thing, what I'm trying to think of is like, do we use this pointer when we go in here? Yes. Yes, we do. Right? But we only use it in this case. Otherwise, oh, hold on a second. Oh, we still have the same problem. Because we need to assign this up here. Wait a second. I think I'm realizing the issue. Parent left needs to change to that, but we need to get a new parent. Hold on, I need the index of the parent. Hold on, I have an idea. I passed down the parent, but I need to know the index of the parent. So I either keep it on the thing. I think I'm just going to keep an index on here. And then every time we make a node, then we just give it an index so that we can reference to it later. Is the dust the same as the theme right now? I think it should be updated, but if it isn't updated, then I'll give it to you. BVH nodes dot count -1. Okay, so I'm figuring out how to do it. So the parent, so int p index equals parent index. Now left child dot parent gets p index as well as right child. Yeah, I set up the indices, but then I didn't finish setting up the indices because I got distracted. But obviously there's more that I have to do here. Okay, so the parent left, right. So instead of, we need to get a new parent. We need to get the new parent. So how we do that is we get BVH node parent, just reassign the parent after we expand. Hold on. BVH node pointer nodes equals castVec whole BVH node. Okay, so we will cast this. We'll go whole nodes PIDX. And we're going to do the same thing. We have to also recast it at the end here. And then get the parent once again. Okay. Motherfucker. I still have I still somehow have a heap corruption somewhere. This is getting to be a mess though. I'm guessing that it's got to be this. It has to be when we hit the bottom and we reference the parent. All right, let's make it even more index dependent. Instead of passing down the parent, we'll just pass down int PIDX, and that's literally going to be it. And then we can get the and then we can just cast it like we do down here. All right, peace out, Ash. All right. All right, so we recast it every time, and instead of giving left, we're going to give that. Okay. Did that work? I think it did. Okay, so there's some case that I'm just like not thinking of. The kid I babysit is awake. All right, good luck with that. There is kind of this thing in the middle, but it still is pretty good. I wonder why these triangles are bugging out like that. But I think that that's a rendering issue rather than an us issue, perhaps. Oh my gosh. There still is. Render. Oh, it has to do with this, I think. When I don't have this, then it crashes. I don't know why. How did I fuck this up so bad that causes it to crash? Like what? What? Why is this? Why is this required for it to? It's not telling me anything. Is it because I... No, it's not, because I just tried that. Like, what is this seg fault? It doesn't seg fault if I have this line here. And that line, all it does is render the wireframes. Oh no, it's still seg faults. Oh yeah, it's still seg faults. You're refreshing the PR page? Maybe they don't look at it very often. We do cast leaf indices to size T. And if I just do the wireframe, we're not gonna die, right? No, yeah, it has to do with rendering the triangles, I guess. Do I touch the faces after? I don't think I do. I don't think I do. Auto pairs for quotes. It has to do with copying and pasting. Like, for example, I want to write a print statement here. That's going to print it out. And I want to do this. If you write an auto pairs, it's going to go here. And you have to go back. Or, no, it doesn't. It doesn't do that. It's for replacement. So if you do this, now your cursor is here. And what I want to do is I want to copy this name into the quotes. So with auto pairs, what would happen is I would do this. Well, I would not have it deleted, right? You do that, and then you would get to the point where you have two things here, and then you would do this, and now you have to put another thing here at the end. When I'm kind of explaining it bad, but a lot of times in Helix, you're doing Shift R to replace, and or P, you know, and if you do that with auto pairs, then it's just super awkward. It's just very awkward to do. I want to assert leaf indices node first index plus k less than let me add the assert there. I expect it to fail. Dude, like, what the fuck are we talking about? What is P? Isn't replace under C? Shift C is replace. It replaces what you've yanked with what you've yanked. So we're just seg faulting. We're just seg faulting to seg fault. Why would we be randomly seg faulting though? It's so strange. It is so fucking strange. I remember a couple of years ago I was on a school trip and there were ring souvenirs and I put one on and it stuck on my finger and this... Oh. That's embarrassing. I'm sorry. That is embarrassing. Oh no. That is embarrassing, yeah. That sucks. I'm sorry to hear that. We can add a couple more certs. I don't think that we're going out of bounds anywhere, but I think we have some corruption on the heap, my friends. I think we have some corruption on the heap, my friends. I think we have some corruption on the heap, my friends. Have you taken a look at Steelix? I've not. I probably should have, because instead of doing that, my life has just been fucking pain because of this. So you know what, maybe I will take a look at it to take my mind off of the torture that is whatever the fuck I'm doing right now. You know? You're spaghetti eating? Spaghetti's good. It kind of makes me bloated though, so I'm not like the biggest fan. Just personally, you know, kind of just fucks me up pretty bad. You feel me? Yeah, I never actually like fuck with the array until we're at the bottom. Until we're here. here's where I expand the shit. So yo, what's up, 3-leg chair? Oh wait, you do need to start. You need to have this because it needs to go down. The parent can be -1, but yeah, this is correct. This is correct. It took your 4th leg away? Yeah, do you just like fall over all the time? That does sound like it sucks. To be completely honest. That doesn't sound very rad to me. Like if I no, because no matter how far you recurse down, unless our leaf indices, when we expand the leaf indices, but I don't think so, because we go into a different one every time. So how am I going out of bounds? And why? Yeah, you can find it on my GitHub. It is only for Helix is it .toml, so unfortunately that is the case. The only thing that I can think of is that it may be like specific nodes or something. Oh wait, hold on a second. We do set left and we do set right. So therefore, we should only have, these should only be roots. Those should only be roots. And we do enter here at the end. You can hire me to port it to Lua. Am I coding for great good or great bad? I'd like to say the great grit or good. I think I try to make things that have quality, as much as possible. Even though right now that does seem to be a bit funny, because this is probably not the most quality code of all time. If I just do, yeah, but if I do zeros, then that's not gonna be really good, huh? Is there a case where nodes just get initialized to bad data? That's what I want to know. Hold on a second. Hold up a second. Was that it? I love OpenGL. I love OpenGL. I love it. I love it. I love it a lot. I love it. Love it. Love it. Love it. It's the greatest thing I've ever seen. I love it. It is magnificent. I love OpenGL. I love OpenGL. I'm like so close to doing a Trump impression without like consciously trying to do it. I love it a lot. I can't do impressions. It's actually hilarious how bad I can't do impressions. Hello, America. Quite frankly, I love America. I love America. I love OpenGL. It's the greatest. It's gonna be great. I love it. Okay, so why is this not split more, huh? Well, maybe I should just take my W's. Take the W's. Where there are W's, you take them. I think you wanna split more. I'm not gonna lie. I think we do want to split more. But yeah, the reason why you want to split more is because we're gonna be doing GJK now, and so you definitely want to have. I want to only like be testing against like 3-4 triangles at max in a leaf. You feel me? You feel me? Like the problem is, so this leaf, for example, what happened is it got this leaf, it split it down the middle, and nothing really came of it. But we need to be splitting these. We absolutely need to be splitting these. But maybe they do split and our ABBs are just lying to us. That's also entirely possible. It's only the bottom level children that we're drawing, right? Yeah. Yeah, I don't know. Obviously, if you do one, then we get absolutely owned. Oh, actually no. See, it still is. There are just points where there still are some issues. Like in the middle, where we don't split. Let me try something. Instead of if centroid is less than the split pause, let's see Paul Allen's card. Let's see if point in AABB centroid. Sometimes I just let the intrusive thoughts out. Like that was an intrusive thought right there, the Paul Allen's card thing, and then I just like I usually don't say it, but this time I was like, fuck it, I'm saying it, you know? Let's try the whole centroid. Okay, the same thing happened. It's the same thing. It's we're gonna make rendering great again. Neural rendering. Dustmite is woke. Joe Biden is a graphics programmer. He uses DirectX. Heathen. I need you to march this. Yeah. I have a feeling that because we're using centroids, it's not exact enough. I think it's because we're using centroids. That we sometimes get ones that don't have anything in them. And then we don't split enough. Wait, but actually, you know what I'm thinking? I'm taking back my thing. So if you're walking on this surface, like right, like let's just walk around in this surface to simulate what's going on here. If you're walking on this surface, and then you don't fall off the world, if you're walking on that surface, really you're only testing against these two triangles, bro. You smell me? My thing with this was okay, and then you got it right down the middle. But since it's BVH, you're also going to be testing with the shit underneath the ground, bro. And so that's the part that I'm having a bit of some problems with, bro. Like I'd love to see what triangles are in this one. Yeah, I'm not sure. I think I'm doing it the correct way. It's just if I do this, this just breaks everything, right? We've already done this. We've already done this. It's just infinite recursion, right? Oh. What does GDB say? It's probably going to be like infinite recursion detected. What? Phase indices 0. Lily is not woke. That's crazy. That's fucking hilarious that you would say that, though. Yeah, even it just went did on me. Like, what? Maybe you do have to check right count. It probably is some infinite recursion business that it's like, oh, we can't do this, so that's it's a reasonable thing to check the right count. I'm with you on that one. Let's just try the more basic conditional. And now you get an even bigger one. So I think what happens is that you get this big one, and then it has these centroids, only 2 centroids down there too, and then it splits it down the halfway, and then there isn't a centroid here because this one is somewhere else, or it splits it this way, and then it doesn't find anything to do. So instead of doing this, here's what I'm going to do. I've decided what I'm going to do. I figured it out. Instead of doing this, we're going to clip the triangles. Okay, this is cursed. But I think that this is what you have to do. We have to clip the triangles. Every time we split, we clip the triangles. Oh god, this is gonna get stupid complicated. Oh god, it's gonna get stupid complicated now. Yeah, this is what I have to do. I have to clip the triangles, bro. I have to clip them as I build the BVH. Ah, shit. This is gonna get complicated. Okay, so we sort the array as we go down with the i's and the j's. And then we figure out, for the left child, which j's somewhat go into the bounding box of the I of the left side. and then which eyes go into the bounding box of the right side, and then you clip those on the ABB plane, and then you keep recursing down with those new triangles. Holy shit, this is gonna get complicated. I'm gonna rewrite perfectly in Zig or Rust for no reason. That might be the truest thing you've ever said. You should tweet that. You should tweet that. That is... I thought that you were like, oh, I should learn Zig. Are you just saying that to like... So that I'm like, oh my god, that's so true? Like, is that what you're doing? Do you even believe that yourself? Fuck. Okay, so here's the problem. If I do this, every node is going to need its own vertices and faces. Okay, that's revelation number one. Secondarily, every... Fuck. That's a lot of memory, brother. That is a lot of memory, bro. That's a lot of memory. You hate to see it. Wait, so let's say we recurse down in bounding boxes. Get to the bottom, right? Can we reference the triangle? Can we have a master triangle list of everything? Is that possible? Is it possible? That's complicated. But it's necessary in terms of memory, because otherwise you're going to have each node gets triangles, and we copy them as we go down and split triangles. And so you're just going to have like megabytes of triangles if we're splitting these meshes. That's not going to fly, bro. Okay, so how do we do this? I think we need a global triangle list that we are cutting. Yeah, we can have a global triangle list that we're cutting. No, because then if you have a right bounding box that's a big one that hasn't been cut yet, and then and it references that triangle that we already cut, then we're fucking toast. Damn. Unless every time we cut a triangle, we go through every fucking node and replace all of the references to it. Because the thing about BVH is that we have this array that's split that we're sorting by. But now this breaks that assumption, because now we're pushing new triangles onto it. So how the fuck do I go down? Bro, this shit is hard. Oh shit. Someone made a tool called TLDR to shorten man pages, and someone rewrote it in Rust and called it TLDR. That's like everything that I've seen in the past like fucking 4 years. What should be the punishment for writing in JavaScript? I don't know. We gotta throw them in. We gotta throw them in a computer science class, but an actual computer science class. Oh, dude, this is fucked. Okay, so here's the problem, right? We're sorting into left and right nodes, right? But now I want it so that we also clip the triangles as we sort. And then we go down, and then we go down, and then we go down. But the problem is memory. I mean, like, if we clip triangles and then our children get a different array of triangles every time, fuck. Like, is that legal? There has to be another way, no? I think that this has to be the way. Each parent gets a vector of triangles. Each node gets a vector of triangles that are clipped. And then we recursively go down and clip them. And then at the end, we free all the interior nodes. Is that the way you do it? Because I can't think of another way of doing it. If we have a massive array of triangles that we are clipping, we have no idea what's going to be on left or right. Yeah, this is what I need to do. Okay, I don't know if this is the right way to do it, but I think we have to give it a shot. This is going to be a lot of memory. But even if this doesn't work out, then I need to reuse the code anyway once I do it the proper way. So to some degree it is necessary. There's going to be a lot of memory, depending on how far the recursion goes down. It's not going to be pretty, but I don't think there is another way of doing it, unfortunately. So let's say you have a left child, right? You have a left child and it has a first index and a count. We want to go through all of the triangles that aren't in the left and then clip them to... Oh, you saw Pulp Fiction. Yeah, I read that and then I didn't say anything, but yeah, I saw that. That's cool. Did you like it? I think it's good. It's probably my favorite Tarantino. I mean, that's like the basic take, but when I saw it when I was like a teenager, it was like, oh my god, it was like the coolest thing ever. I think it's alright now. I've kind of like become a bit lukewarm on Tarantino and Wes Anderson stuff as I got older, but I still think it's a good movie. I do like Bruce Willis in it, mainly. I watch every Tarantino film. I feel empty inside now. Yeah. Yeah. So we have a left child. What we need to do is we need to clip all of the triangles that aren't in the left child to be in the left child. Or actually, clip all of the nodes to this bounding box. How do I do that? I know how to clip a triangle to a plane. I don't know how to clip to a bounding box without it getting super ridiculous. Classify vertices. For each edge connecting vertex A to vertex B, evaluate how they sit relative to the plane. The actual... Okay, so it says that there are 4 bounding box planes, which... Aren't there 6? Maybe it's talking about 2D. It might be talking about 2D. So to do this, we need 6 planes of a bounding box, of the bounding box. Luckily, they're all axis aligned, so we can just hard code calculate them, right? But I do have to fucking calculate them. Holy shit. This is gonna suck. We have a center, we have our extents. Sorry, I just hit it. If there was 7, that would be even worse. She showed me the lyrics to the song saying that I'm not a burden to her. Well, that's sweet. Okay, so if I want to compute the planes... If I want to compute the planes, then it's just... Oh, actually, it's not bad. It's not bad. Because the planes are just cardinal directions, actually. Right? So you just have one that's negative x. Yeah, no problem. It's always axis aligned, so we're actually so good right now. The only hard part is going to be the triangle clipping stuff, which is going to be more complicated than my other implementation was. So that's gonna be a bit of a problem. Oh, I was like, why isn't there 6? I can't count, apparently. Okay. We also need points on those planes, right? We need points on those planes. We need points on those planes to do the D. To do the D. Okay? Now, how do I do that? I don't really know. We want the min x here. we're only doing left child, by the way, right now. So this is going to be dot min x, and we'll just do. Okay, actually, let's just get for now. Let's just get the AABB, just so that we don't have to refactor this later when we eventually make it some other function, because that's likely what we're gonna do instead of just having it just randomly in this spot. But have you tried functional programming? Have you tried functional programming? I think that I'm doing this correctly. But really, like, it's kind of hard for me to like visualize it. So yeah, I'm not gonna forget to put these to the numbers, because I was totally about to forget to do that. Okay, lock the fuck in. All right, so we need to clip triangles using all of these. This is going to be really fucking hard. This is going to be really fucking hard. This is probably going to be the hardest thing I've coded so far in this. Okay. Okay. We want to go through all of the current triangles, which we haven't really taken in yet. Actually, so let's just get that out of the way, right? So we have our current triangles, which we'll just cast them. Current verts, because we aren't going to touch it. It's going to be parent vertices, right? And we want to do the same for the faces. God, it took me so long to fix those stupid bugs earlier that now that we're getting to the interesting part, I don't have the energy to do it. But I'm still going to do that because that's what I fucking do. Okay. We're going to loop through all of the faces, and we will put them into the triangle clipping equation, and then push them onto the new triangles. The problem is that a triangle can get clipped multiple times, right? So until we have the final triangles, then we can't really push them onto new triangles, onto the new vectors. How about tried Python? Yes, I have done Python. I wouldn't say I tried Python. It's not like a language that you really learn. You can sit down and just code it. You know, it's not like a language. It's kind of like the equivalent. Python is like the equivalent of like doing a coloring book sort of thing, you know? But, you know, it's alright. Fuck. Okay, let's do it. Let us do it. We're going to need another function that clips a triangle with all of the 6 planes. And then we get the triangles that it clipped at the end. How am I gonna fucking do that? Shit. Okay. Do I want to put in the raw vec3s? Is that what I want to do? I think so. I think we'll put in the raw vec3s and we'll get raw vec3s out. And then just assign them to the thing. Because if I just take in like indices and a vector, things get messy. We're creating new vertices anyway. Yeah. The problem is that once we start doing this, we're going to start having a lot of duplicate vertices. That's a big problem. Start to have duplicate vertices. Because we put in two triangles that are right next to each other. And then, they share a point, and then we fucking end up with the same point twice because we put it into here. Can you listen to Jack Stauber? I think he's got cool stuff, I guess. I was never like really into it. I think the videos are cool or whatever. I think I've seen like a couple. Fuck. So the face will reference what's in point already. We'll copy the... Can I say hi? Hi. Hello? What we're going to do is we're going to copy it into new points and new faces immediately. Because we are going to have... Ah, shit. The left and the right. We can't just copy it. We can't just copy it. We do deduplicate as we go along. We deduplicate as we go along. We deduplicate as we go along. We deduplicate as we go along. like Muskite. Elon Musk. I'm not. I've got nothing to do with Elon Musk. We need to do this for each point. Okay, so if we have found it, we don't need to move along. We want to keep a int index that we will set face indices p equals index. So we're hooking it up to the point that we already found in there. Otherwise, we want to add it to the points array. So we'll do that by grok. Oh yeah, yeah. Yep. Grok. Can you write this code for me? That would be awesome. Why am I doing that? We're gonna expand by 1, and then we're gonna add the point there. Equals points face indices p, and then we will set it to whatever this points count minus 1. Okay, so that's all of the points have now been consolidated. Our face knows where they are in the other array, in our current array, right? Okay. So this deduplicates as we go along. Grok, but grok with the C, yeah. That is it. Okay, so now we have our 3 points for our triangle. Now we can put it through the clipping algorithm using the 4 planes. We can use the clipping algorithm that I did yesterday and put it in. The trouble that I'm thinking is, like, how do I put it into a function? But we are eventually just going to want to go through all of the planes. The problem is, as we go along, the triangle will start to fracture. Let's say it's on the side and it needs to be cut twice. So I'm not really sure what's going to happen. We might actually have to have a Boolean cannot cut, and then while not cannot cut. That's kind of backwards, but you get the idea. And then, like, if we didn't cut it anymore, then we just exit out. Some guy said that God has something to say and quoted a completely unrelated Bible verse. Something to say about people that use they, them pronouns. Was God really spitting about they, them pronouns, bro? Was that really on his mind? I don't get the whole religion isn't woke thing. You know what I think, bro, is that religion is, like, totally woke. I think religion is inherently woke. It's just that religion and the texts that we have for it are just so old that now our understanding of like wokeness has changed. Like, I feel like if they wrote a new Bible, shit would be like insanely based. Like, a dog that returns to its vomit is a fool who repeats his folly. Bro, that's bars. That's bars, bro. I feel like if we did have the Bible too, I feel like it would be insanely based. It would be all about inclusion and shit, and I don't know. I think that the Bible is just too old. That's the problem. That's what I think. I think conceptually religion is pretty based, yeah. It's opt out rather than opt in. That is crazy. Here, none of our schools have religion except for the ones that you pay for. So that's pretty opt in, I feel like. Okay. Okay, I know it's cursed, but just hear me out for a second. We're going to go through all the 6 clipping planes, and then we will clip as we go along. And if we did clip, we need a break and then go through again, and then clip the new triangles. But now we have more than one triangle. So it's like a recursive thing, actually. So we break out, and then we now we recursively call clip triangle. Oh, I named this clip triangle. What am I calling this? Clip the triangle? Perform clip. Shut up. I'm not talking to you. And it's crazy seeing an American. Yeah, I mean, they say that, and you may hear about that overseas or whatever, but I feel like even living in, like, you know, the South or whatever, my, like, sister is, like, pretty progressive friends and shit, so I don't really think, like, it's as bad as it seems overseas. Like, maybe in, like, I don't know, fucking Arkansas or something, but, like, personally, I think that's probably just, like, the sensationalization of it. It's pretty chill. Katowice? That's how I do it. Probably because I know about Counter-Strike, though, and they have tournaments there. When we perform a clip, we're going to return the triangles. We're going to return a buffer of triangles that we then push on. We're going to push them on. Nah, yeah, it's cooked. It's fucking so fried. I'm so close to saying it right. All right. Yeah, I tried. Fuck. This is so difficult because it's like a recursive thing. Maybe we don't deduplicate until the end. Maybe we don't deduplicate until the end. Maybe we just actually go through with a new buffer itself and just push them onto their own buffer. Because if we don't, it's going to get so fucking complicated. Like, oh my god. If we didn't cut, then we break out. Else, we need to push what we cut onto a buffer and then feed it into this same function again. But each time, like, this is so fucking complicated. Okay. So this will be the top level function. And what we'll do here is we'll just have new faces, new points, and we'll initialize it the same way. You're buffering it? Nice. What do you mean by buffering it? Okay, so we're gonna we're gonna set up the same thing that we have in our parent function over here. We're gonna call this new faces. Actually, yeah, just call it new faces, new verts. Okay. So we're just going to push on to new verts to initialize it. Exactly what we're taking into here. What we take into here, we're just gonna push it on like it's new geometry. So onto not expand bits. Vector expand with points 1. Points 3. And what we're going to do is P0 equals points indexed by face indices 0. And we need this. This what we'll take in. Actually, you know what? Since we're doing this, instead of taking in a face, let's just take in the actual points. That'll make this just a lot clearer because there's no need for us to have indices because we're going to break everything right now. We're just gonna fucking break everything because that's the only way to do it. How come I have Windows 11? It's Windows 10. I have Windows 10 because it's sort of necessary for this computer. What color eyes do I have? Brown. With the system design thing. Sorry, I didn't catch. I haven't looked in the chat in a second. I have an ego problem. I want to accept it, but from inside. I don't know how to do it. That's hard. I don't really know. I have an ego problem too, I guess. But I think that that's just called bipolar, but... Okay. We aren't expanding. We're expanding new verts. That's what we're doing. That is what we're doing. At the end, we will, of course, free new verts.buffer. So a lot of malloching and free going on right now. But later, we will set up stack allocated stuff for this. Okay. Or we can return these, but let's not worry about that for now. We're going to expand new faces. 1. Nearest BVH primitive, and then test against the one triangle inside it. Do anything going over just scanning affected triangle? I'm tired. If I go for the nearest BVH primitive and then just test against the one triangle aside it, do you think I'll have issues over just scanning affected triangles? Just going to say no and do it, then inspect the SDF. I'm not sure what the question is. I feel like you should be testing all the triangles with... Are you talking about just like at the... when you're in a leaf? Is that what you're talking about? When you're in a leaf, what you want to do? Redefinition of A. Okay, so we have our face and we have our points, okay? And from here, we will push them down into the perform clip function, which it will just take in the verts and the faces and the planes, okay? So we will put in new verts, new faces, planes, plane points. And then this will clip all of the triangles that we give it. I feel like I'm just gonna write another recursive function. Like, what is this? What are we doing? Okay. So let's figure out what we're gonna do here to make this happen. So we obviously need to loop through all of the faces separately and loop through all of the planes on top of that. No, you want to loop through... Fuck. Let's just write it in one function. I'm tired of abstracting things. I think you want to go planes on the outside. No, the leaves are done. This is the affected triangles that the bottom leaves hold. Yeah, that's what I was saying. That's what I was saying. The triangles inside of the leaves, you're saying. I mean... What I do is I just check if they have a point inside of the bounding box. and then I just put them inside of it. But then I don't really care about about duplicated triangles since I'm just doing collision. So, do you care about having duplicated triangles, or are you just trying to have one triangle on each? Because if you want to have one triangle on each, then the centroid test should already do that. You know? But I'm not sure. Okay. Yeah, I'm just wondering if there's some way that AABB can be sized that mess with the nearest point. No, this is not the blast. This is the SDF gen. Oh, I see. Yeah, I'm not sure. Yeah, I'm not sure. I think it's not like the end of the world to to do it. I'm abstracting it again. All right, let's get fucking serious here. I'm just realizing how disgusting this is going to get in a second here. What? I just copied this. Okay. So obviously we can't take all of this code, but the idea of it is going to be largely the same. This is not going to be simple at all. It's going to be very, very hard. All right, peace out, Lily. Like, what if somebody angles a triangle on an angle and then poked another through it, and they didn't get the poke bit because of that? Yeah, I'm not sure how your BVH is constructed, if it's axis aligned or what. So this SK thing is important. We also need that. We need to determine which one is outside of the face and which one is on the inside of the face. And so this is all very important to have. Okay. So the normal is going to be the plane. Or actually, this is going to be the face normal. Which we'll also have to deal with. I'm using a KD tree. Well, then that's axis aligned, right? I feel like then you have to decide if you want to do what I'm doing right now. which is clipping the triangles, or you duplicate them into the leaves. Like, different leaves can have the same triangle, but then that affects the BVH, the size of the BVH. Okay. So P in this case is plane point. Normal equals plane. So that's where all that comes from. We want to have this, so we have to have vec3 points equals cast vec points vec3, and we'll call it points just like this, and then this is going to be face. We don't have to worry about number of splits, just have splits. I don't think that this is important. The prims are not aligned. The prims encompass the tries. Oh. Oh. How come they're not aligned? Is there a reason that they have a different plane? Because if they were aligned, I feel like it would be faster for comparisons, no? Points face indices K. Yeah, all of this is fine. I don't really know what this is. I don't think it's necessary. Okay, so these checks we can get rid of for now. Let's not worry about them because they're taking up space. Okay. So inside and outside vertices, this is where we split inside. So if splits is equal to 0, else if splits is 3, else then we clip. So this all goes into this. If splits is 0, then we just put it on the inside of the plane. And if splits is 3, then we want to remove it from the vector of points. Or we want to remove the face. Because we only want what's inside the plane. Because the BVH primitives are just the centroid indices and extent of the triangle. But that's axis aligned, no? If it doesn't have axis, which is like OBB orientation, then that should just be axis aligned. If it has a centroid and extent. Fuck. This problem is so hard to solve. This problem is so incredibly hard to solve. It's ridiculous. Layman stat to grid. Super tired. Yeah. Yeah, I mean, I think what you can do if you want to do that, then you can just check the triangles to see if they intersect the bounds of the extents at all, right? Just, I literally just have a function that just checks the points if they fall into the bounding box at all. The optimization there, I guess, is so that you don't have to check every triangle, is to like have some sort of spatial hash to make sure that you don't have to like check every triangle. But if you're doing a BVH and sorting that array as you go down, it's possible that you could just use those indices themselves without having to check at the end. If you're doing that I and J method. In this case, is the face already added to the vector of points, or what? You know what? Let's not do this. Let's not take in the face. Let's actually take in a vec3 and then process it as a new triangle inside of here. Let's process it as a new triangle. We are going to need a J normal though, from the original face. That way, now we add it to the vector. Now we add it. Now we do the vector expand. Only once we've detected that it's inside the plane. Well, this is a KD tree, not a BVH. I'm just trying to minimize before I do anything on the SDF gem. I see. Nested testing the prims together seems pretty crazy, but maybe it'll optimize it. I don't really know what the once again, I don't really know how the SDF gen ends up going, in terms of how you calculate it and how you whatever you have to do. So okay. So everything else goes in here. So instead of using face indices K, what we'll use is, oh, fuck you. Yeah, we have to take in we have to take it in as okay, so we're gonna do it like that. Mains faster bake. Well, that's good. Yeah, it sounds like you're maybe grouping them together, which seems good. If as long as the bounding boxes can work together, and that isn't going to make anything, incorrect in any way, then that sounds good. Okay. So we're interpolating the face points once again. Now this is the point of the clipping triangle stuff that I never really, didn't really understand. But we only want to actually keep the inside triangles. So this makes it a lot easier because we don't have to deal with outside at all, which is really, really nice. So all we need is inside vertices. And so I'm just going to put in points here, and then we'll put in new points, which should be here. This is all inside of here. We're going to get rid of a lot of it, though. We're just going to do it like that. So this is points. And a lot of this is way more complicated than it needs to be. So that's good. We don't have to do it this crazy. Okay. So let's figure it out. So here we just count if they're in or out, which is nice. We only need in. So if I don't really know why that's backwards. If SK is true if it's out. So if not out, then let's do that. So if in is 1, then if in is greater than 1, then we'll do 1 inside, which is what this is, and then otherwise we'll do 2 inside. Okay, so let's get rid of the outside. Let's figure out how to clip it. Okay, so we are going to once again use points. And this in IDX instead is just going to go into face points, which is our replacement for that. And then we will use points count -1. Similarly for the faces, so this is our inside equals this. Oh, right, we already added the new points, and now we're adding the face points. Okay. So now instead of inside faces, we have faces. And so we're adding this new face. Which is IA, IC, and IB. Which is correct. Those are the 2 new points and the one other point. So that's correct. Now let's move on to the second case, which is more complicated. Okay, second case, we have, once again, we have to rename this stuff. Points, face points, and points count. faces, points, yada yada. Yeah, this is a lot of, because I'm tired, I will undo my changes before I go to bed and store them in your paste bin. Yeah, that is probably a good idea. I wish I did that more often. I hope you have a restful night. Okay. So I'm not sure about this vec3 length new sub thing. The whole point of it, right, is that if you cut a triangle and you've got 2 on the outside, then whichever is closest you want to use for the other one, you know, that was the idea. I don't know if it's a correct idea though. I don't know. It's weird. That means it's going out of the index. I don't know. That sucks. Okay, technically this is the code correctly ported over. I don't have a lot of confidence that it's going to work, however. I don't have a ton of confidence. So if we're inside, if we're outside, otherwise here, then we return true because we clipped it, which means that we have to go again. And then so this is it. And then we call it with perform clip, I think. But yeah, it is tricky. But yeah, so we'll have this vector on the outside, and we won't add on to it right away, but we'll just pass in the vector as it goes along. Oh, but it needs faces to start with. Oh my gosh, that sucks that you got that right when you were going to sleep. Yeah, so I mean I could have technically 2 arrays. I don't want to though. I think I might have to. No, it's not playing nice. Oh no. Oh my gosh. If we pass in... Oh my god. We can start with a potential face and then try the cut. And then we can call clip triangle against plane with new verts, new faces. Yeah, just go through all the planes. The return makes the cache null ones. Well, that sounds like a pain in the ass. Not gonna lie. Okay. Well, the cache saves it from crashing. Oh man, that blows. It's a mystical crash. That's a funny name. This is the hardest thing I've programmed in a while, so I'm sorry if I'm just like quiet right now. It's kind of hard to talk through what's going on right now, but just know that I'm very happy that I'm alive right now. It's a lot of great fun. This is not easy. This is really, really, really. I think my fingers after this are gonna need a break. Maybe some ice. I don't think I've programmed something as hard as this in a while, like a hot minute. Oh, fuck. Okay. Okay. Beautiful. Beautiful. Are we fucking finished? You're joking that we're finished. Now you're being fucking funny that we're finished. Are you kidding me? We actually got this done. You're being fucking funny. You're being a funny fellow. Is it the condition? Well, knowing me, I would spend like 30 hours doing it. So you're definitely better equipped to handle finding a bug. Unlike me, it takes forever to find bugs. Okay, so we get to the end, and we need to figure out how to put new verts and new faces onto yeah. Okay, so here's what we do. We want to go through actual points count and then just push relevant points. This is going to be such slow code, by the way. But right now, I don't know of a faster way of doing it. ND is less than Mindist. Yeah, I have no clue why that would crash it. That sounds sucky. That really does sound sucky. I'm running out of brain juice at this point. My brain has been working on like overdrive. Hold on, this is new faces. Can you fuck off? Okay. We are just going to deduplicate the points as we go along, which, to be honest, I shouldn't be doing this. I should really just like put them on the other buffer and then just add the offset to it. That's what I should do. I'm just scared. I'm just a bit scared. Yeah, fuck deduplication. Fuck it. If points, we're gonna manually do a resize here. If points capacity is less than points count plus new points or new verts count. I put the condition that checks if the prim's index is out of bounds and the checking if affected index are in vertices bound to do less statements. Cause it to pass when those two things weren't in bounds and hang. Oh, I see. Oh, yeah. Maybe there's some edge case there, huh? Failing to hit then. Ah, yeah, there might be some edge case. Like earlier I had an edge case with a pointer, so yeah, especially with recursion it can be a thing that sucks, yeah. We need to do the same thing to the faces. Okay, I just wrote some cursed ass fucking code. Um, that involves manually resizing some vectors and a bunch of crazy fucking shit, to be honest. Like, this is some crazy fucking code. I'm supposed to return a vector here, but I don't think that's actually what we're doing. We're just going to add on to the vector. And so what this is going to look like in practice is that we're going to have these and we're going to have these, and then this new verts and new triangles are going to be what we well, I'm going to see why it's -1. Unfortunately, I think that we need to have current verts and current faces get copied into new verts and new triangles. We need to copy it. Oh, did you figure it out? Oh, wait. We want to clip them into both bounding boxes because we're splitting them into... Oh, yeah. Fuck. Oh, shit. I'm literally doing double the work. Fuck. Oh, yeah, that's a problem. That's a fucking problem. That's a problem for later me, though. Maybe later today. Basically, I'm splitting the triangles into two, but I'm only keeping the left half, and so I'm running it for both sides. I didn't really consider that I could do both of them at once. It would be more complicated to do so, for sure. Like, definitely non-fucking trivial. That's for sure. So let's mem copy into new verts.buffer from current verts. It's a lot of shit that's gonna have to happen. This is cursed. Okay. So we mem copy into it, and then we go in a loop over all of I, and then we do that. Yeah, the problem is... And then we give it to the child. There's a few problems here. We're just gonna not think about it, huh? We're just not gonna, you know, it's fine. If size is on the blast. What does that mean? I have to start at do I just clip what's inside the bounds? Maybe I just clip only through I. What did I call this? Clip triangle. Okay. How do I get what's inside? Whole BVH indices. No, that goes into faces. Oh, did it collapse? Fuck you. Okay, so that is the code for the left clipping. That is the code for the left clipping. So I'm just going to put this in raw brackets and then just copy it over for the right side. Once again, technically you should be able to do the left and the right side at the same time. But we're not living in that world. There's a lot of memory going on here, though. It's only when we get down here that we can free the parent.vertices.buffer. And we need to free it, or else we're going to have an insane amount of memory. Like, this is The amount of memory is absolutely disgusting. But I don't know of a better way to do it. There might be. There might be. Might probably be. But for now, that is what it is. So now we're just going to do write AABB. And from here on, it should be very similar. We just need a different start and end index. Which is, you start at I. Oh, wait a second. Oh no, you start at I, yeah. You start at I and then you go to I plus right child count is fine. Okay, so these vectors for new verts and new faces are obviously going to have to change names because they're two different things. One for left and one for right. Actually, you know what? You know what we should do? We should just do right when it's time to recurse into right, and we should let left be first. That way we might actually be able to keep these arrays, no? No, we need to reset them. We would need to reset them. Yeah. It's very easy to cause a memory leak here. Fuck you. Yeah, I have no clue. Yeah, that's been happening recently. I think it's like something weird is going on. Okay, so we give the parent, or we give the left child the left child the array. That way when it gets down here and it's a root, not a root, a leaf, then it can be fine. Left vert's declared here. Yeah, no shit, man. Oh, it's just, that's the something that I hate about fucking clanged, is it like tries to predict, hey, you meant to do this. It's like, dude, you don't need to give me errors just because of renamed variables. Okay. And now all we need to do is write child dot vertices equals right verts, and right child dot faces equals right faces. And I think we're just about ready to run out of memory. I think that that's what's gonna happen. I don't think I'm really ready for it, to be honest. The good thing is that we're only doing left before right, which should theoretically cut down on memory usage by some amount. Theoretically. Okay, are we ready to send it? We're only freeing, we don't free the parent. We only free right child dot vertices dot buffer and left child vertices dot buffer. Okay. For an acceleration structure, it sure is fucking slow. Okay, are we ready to just send it? I mean, we've done a lot of coding, so got no clue what's gonna happen. Doubt we're gonna go anywhere. Yeah. Okay. Let's see what GDB says. Invalid allocation size. Where? Subdivide try BVH. Mem move. Okay. We didn't put it in the root. Do I have to copy it? Do I have to copy it? We shouldn't actually... I think I'm just going to do this. Because... I mean, it is setting the same buffer to the same pointer, so it is kind of sketchy, but... Wait, really? It's not that? Is zero memory. Clip triangle. And realloc. Oh, I didn't handle that. That edge case. That there might be zero... At what line? 620. It's this points buffer realloc that has nothing in it. We should handle that beforehand. Restored the old code. Yeah, sometimes that is best. Wait, hold on a second. You had to by hand? Oh no. Was it a lot? That sucks. Malik and free. Malik and free. Okay. Motherfucker. $625. It still is having trouble reallocating this buffer. Maybe because it gets freed somewhere. Let me prove it real quick. Let me print the pointers for this fucking buffer before I lose my goddamn mind. I just don't understand. Doesn't respect the class of structs. Yeah, I mean, there's probably just some edge case in there. I'm guessing that the size is invalid then. I don't know how this would... Doesn't make sense. Hold on. I don't actually set the counts, do I? Oh, I add new verts stud count. Alright, I'm closing the window. I'm scared that there's a bug in here. I initialize them before I send them in, right? I definitely do. All right, peace out. Thanks for hanging. Can I try without the clipping? Just try without the clipping. Do they just mem copy all the way down and it's fine? Yes. So it has to do with the clipping. It has to. Absolutely has to. The clipping takes in the left verts and the left faces buffer, which we just mallocked and mem copied into. Here's a question. If I don't free them, which we're going to be causing a memory leak on purpose. No. It's not us freeing it. That's the problem. If we only do left children. No. And it's definitely this, right? Like, if I get rid of this, then we're gonna be fine. No, we still fucking die. Why do we die there? Mem move 978. Oh yeah, so I should check, I guess. If they have 0 in them. Also, now I'm realizing that us copying all of the parent vertices just means that we're copying the same data every time and we're not actually going down any. There's actually no point in mem copying into them at all. Because you're just going to put the new triangles in. So there's no point in even doing that. Okay. Okay. Did I do it? Oh no. I had all of this commented out, right? Fuck. There's definitely some 0 sizes that are getting handled with. Hold on a second. New points needs to be casted after. Same thing with MFs. Needs to be casted after. Turns out your SDF bigger, the function to traverse down the node is broken. It stays at the father node. Oh, I see. Does it just get stuck or something on a split or something? Free heat block after it was freed. Where? In vector alloc vector expand clip try against plane. Which is the bottom level function. Clip try against plane. Vector expand what? 331. Vector expand the points after it was freed. Okay. I'm not sure how that could happen. Yeah, that does suck. Well, I hope you figure it out. After it was freed. But I don't free it anywhere. I don't free it. Oh, I mean, technically none of that is supposed to happen. We're just supposed to go from a raw. Okay. Critical error detected. Trace breakpoint trap. Shut up. Clip triangle 674. This is getting ridiculous. I'm thinking that these points face indices have to be referencing within the interior whole BVH indices I. I think that we're not supposed to be going off of these faces, but the other ones. But before we even fix that, I mean, there's the bigger problem, which is 674, which is this free. It says that we can't free it. A init vector sets it to null, right? So I don't know. That shouldn't do anything. $674. We'll just move it into here. Doesn't really make sense though. Ah, fucking Christ. Like this is ridiculous. Yeah, it's 668 here, yeah. That was definitely a bug. Not sure about the rest though. We could try just clipping once, maybe. I don't know. The recursive clipping is a bit much. Not sure. I'm at the point where I might just print out everything that happens to that buffer. I don't understand. Doesn't make sense. There's something that I'm not seeing, I guess. If I do this, then obviously it's not going to go into there, and it's going to be fine. But somehow it taking in new verts and new faces here. You know, what I didn't expect, actually, now that I'm looking at it, what I didn't think about was that it's going to add the triangle to itself 6 times if it falls within all of the planes, which is something that I didn't consider. Which is probably very fucking stupid of me. I didn't really think about that. There's 6 planes, and Yeah, I mean, it needs to give actually an integer back that tells us what to do with it, actually. But I don't even know if that's the problem that's happening. Like, I don't understand how there's like a memory problem, per se. The index is just nothing? What do you mean? What do you mean? Here's something. If I don't do this and don't do this, will it work? Okay. So I did math wrong here. That's the problem. It's the father index, all of them. Maybe it just splits into a million nodes. Int index equals I plus points count. Let's try it one at a time. Let's just try the points. Points work. Now let's try the faces. And the faces don't work. Okay, so let's try to figure out the faces. Maybe instead of this. Oh shit. Oh wait, no, never mind. I'm just being fucking funny. Fuck, dude, I thought I figured it out. No, not the actual boss. The nearest point traversed dies. What does that mean? That sounds ominous. Oh my gosh, I made a mistype. Uh-oh, my bad. Okay, we still segfault, but we get further this time. Heap free block after it was freed. 331. Oh, we probably need this. Fucker. 669. Not 69. I forgot to turn this into faces count. Yeah. My bad. Did I ever give the father children? I don't know. hold on a second. Faces is supposed to go into faces. Wait, but that makes sense. That makes sense. I'm lost in the sauce. I'm also fucking stupid. Oh my gosh, we compiled. Oh my gosh, we compiled. I'm such a happy fellow. I'm such a happy fellow. It's been so long since we've been actually able to compile that I kind of forgot how it looked. Okay, so now that we're back in business, we need more than just a simple boolean from this. We need an integer. Okay, so instead of doing this, if splits equals 0, we're going to return 0. If splits equals 3, we're going to return 3. And then otherwise, we will return 1, which means that we did cut. Okay, so this will be an int did cut. We will get did cut back. If did cut is 1, or 0. If did cut equals 1, then you want to break. Or 3, because did cut is 3. If did cut was 0, then we want to add it and then return out, because that means that we didn't cut at all. Yeah. The children index are messed up. Yeah, sounds like it. Does sound like it. Yeah, that does seem messed up. They do seem to have some issues, for sure. I don't think we need to exit out or necessarily. No, yeah, I think you want to do this inside, bro. You want to do for the faces outside first, and then the planes inside. And then if you end up clipping, then you return true. Is that correct? If a face passes all of the tests, then we need to add it to the thing. That's what I'm thinking. So now you just go if clipped is 0, then we need to add the face to the thing. But then we're gonna add faces twice. Fuck. Yeah, how do I not add faces twice here? Fuck, why is this so goddamn fucking hard? Like, actually, this is like so difficult. If the clipped is 1 and the clipped is 3, then we are clipping. I want a way without just like nested looping to check equivalencies with the faces we already have. It would be very simple to just go in and then just have a nested loop that checks, have we emitted this face yet? That would be fine, but it's really fucking inefficient, and so I'm trying to find a way to not do that. The obvious way is when a face doesn't clip against any of the planes, then we just emit it, right? But once you have now an array of faces that you're doing at once, right? And why do we have an array of faces? Because it's a recursive split, right? So we split the faces for one time, and now we have multiple different faces, right? That all may have to be clipped multiple times. But I think the simplest implementation is to literally just add it if we haven't omitted that face before. Just literally inside clip, try against plane, check against all the other faces to see, have we added this before or not? And so, that's what I'm going to do, because this is really just an insanely complicated fucking thing at this point. This is insane. So I'm just going to put this into here, and then we'll just do this. So we will say, well, we already have this version here. We'll say we need to go through I think we're already in. No, we aren't. I'm only going to check in order A, B, and C. That's the only thing I'm going to check. I'm not going to do any fancy checks for if the points are out of order, because they should never be out of order, if we're being honest here. Some incredibly taxing code to write today. It's been a very, very difficult day, for sure. Like, holy shit. This is really fucking hard. Because we're basically doing a bunch of shit that isn't necessary. So, it sucks. It really does. What? No member named buffer, no member named count. What are you talking about? Oh. Okay, let's see. Can you fuck off? Does GDP make noise like that? It's so weird. Okay. I'm ready to try and see the triangles. I think how I'm gonna do it, what I was thinking of doing with to debug this is to actually, instead of doing just GL triangles to actually just do GL line loop. Really? We aren't clipping them harder? Let me get rid of the wireframe. Just want to make sure that I didn't turn anything off when doing the clipping. I want to check and can split. Let's do three triangles at see, that seems a bit ridiculous. Really? For all of this clipping I'm doing, really? As cooked, the SDF generates instead of 20, but it's all messed up. Yeah, I think your tree is probably degenerate. It's probably a complete degenerate. Oh yeah, you know what? I'm not actually checking them on the inside. Or oh yeah, I'm not actually rendering the correct triangles. I'm actually just not rendering the correct triangles at all. Instead of going leaf indices, we need to now check the triangles inside of the nodes, because now nodes have at the end their own shit. So instead of faces, it's actually gonna be within the node has node faces, and it also has node vertices, which we will use for points. Oh. Well, apparently it's not supposed to push the father node first. Should push it last. Oh, interesting. Yeah, in my LBVH, for example, I had the root node was at the prim count. Okay, so we're dead. So we're dead. Oh, not node count. It would be node faces.count. Let's get rid of all the asserts because these aren't going to work anymore. Oh yeah, I forgot to change this. This is obviously supposed to be faces. K. Yeah, it's just faces K. And why are we crashing now? Fuck. Oh shit. We oh shit. Okay, figured it out. We're freeing them fuck. We only need to free them if they don't become root nodes. Do we just free the parent at the end? Yeah, just free the parent. Are we fucking serious, man? Alright, let's GDB it. Where? 1078. Here. You have to do it after. I don't know. Okay, fuck you. Oh my god. Why? Like, if I don't free any of the buffers, which is really not what I should be doing, we get this. Fucked up little origami piece. God damn it. We could do this. Okay. Now we get the fucked up little origami situation going on here. And that's going to be the... So that's the problem. SDF generation from... Is that what you're going through right now? Okay, so let's do some tests on some different ways of going about things. All right, let's not go. Let's go GL triangles, because line loop is a bit jank. Not gonna lie. So the whole clip triangles thing is pretty fucked up, bro. Like, we gotta be honest here. It's pretty fucked up. If did cut equals 3, then we return. How about this? Let's just not even clip triangles. And let's just add it to the faces and then return. Let's just see if we can do that. Excellent. We did an excellent job. I just want everybody to know that they're lovely. Okay, so if we can do an excellent job, then how about let's not do a fucking completely dog shit job with the rest of it. Okay, so let's try and figure out what the fuck we're gonna do. Okay, that's the trick here. We gotta figure out what the fuck we're gonna do about this. Okay. Okay, so if did cut 1 or did cut 3, we break out, and then did cut equals. Let's just do one cut. Okay, one cut. We get a few triangles, a little bit of triangles. Let's not do did cut equals 3. How about this? Okay, we start to get somewhere. Okay. Let's do some thinking here. Let's do some thinking here. We should only be searching through our parents' vertices and faces, right? That's what it's all about at this point. Forcing it to use index 0 makes the time shoot up to what it was before that. Well, that's good. At least it's walking through now. So we're going to call it new faces, and that's going to be our parent faces. Okay? Very, very, very simple. And this is going to be our parent vertices, our new points. Yes. Okay, so our BVH indices. Yeah, so this is the problem. This is indeed the problem. Instead of using BVH indices, let's literally just use a fucking local array. I know, crazy idea, right? Let's just do a local array. Let's just literally have a local array that we sort all of the indices from. Let's just literally Like it's not that difficult, right? Let's just have a just go parent faces. Dot count. Okay. Let's just initialize them. And then let's just use that instead of BVH indices. Like literally, bro. Like this is so stupid. This is so stupid. So instead of parent first index, we're just literally going to start at 0. And then we're going to go to I think it's parent.faces count -1. Okay. And then we do the exact same thing, but instead of BVH indices, we just use our indices. We just use our local indices. Very simple. Very simple. And it's just the same logic going down. That's the beauty of it. That is really the beauty of it. At the end of the day, that's just the way it is. That's just the way it is. That's just the way it goes. You know that song? What's the secret of working for hours without getting distracted? Not having a life. It's very simple. It's very simple. There's one trick that nobody's gonna tell you how to do anything. It's just like don't have anything else. Sorry to be doomer about it, but I mean, if I had anything else distracting me, I mean, I would not be able to do fucking, anything. I would never get anything done. Okay. And now we just split it locally. We just literally split it locally. The annoying thing is, now we have to change the I and J things in regards to this or something. The I and the J thing here, for example, we need to not use BVH indices and just use regular indices and new faces. That's the key. And instead of going, well, IDX and I should actually be correct. Bounding volume hierarchies, I guess so. Mine is a bounding volume hierarchy where it clips the triangles on the way down. So it's kind of like fucked up. It's like the amount of illness that is in this function is just intense. So like seriously. What's up, Isabel? Okay, now the question is I think that this is just way too complicated at that point. I think left count at minus parent first index, yeah, we don't need to offset anymore because we're doing a local sort. So I'm just... Yeah. Okay, so let's just... This is always going to be I, and the count will always be I. And then the first index will always be 0. And then this will be this. And then you just do, yeah, that works. And also just use I, yeah. Yeah. Doing buckets and heuristics. I don't really know if there's like more like heuristics as much as like just straight up, trying to split evenly, in terms of the amount of volume and the amount of triangles. I did attempt to do like actual mesh decomposition with like clipping planes, and then I was quickly humbled. And so I was like, okay, never mind. We're not fucking doing that. I'm I'm gonna do like some spatial partitioning business. And so far we're running into problems because of, just not intelligent enough, But that's all right. Okay, so this has to be this, and we've refactored it. I think, by golly, I think we've refactored it. We need to free that. The way you put that cracked me up. I've just been here for too many hours, I don't think we use indices anywhere else, which is a good thing, because I just need to know when we can free it, because I want to free it before we return here, if possible. We may not be able to. I may be completely forgetting something, but okay, also, this first index, we didn't even worry about that because that's not even a real thing, by the way. The first index on the count is not even a real thing because every node has its own buffer now. Excellent. That's exactly what I wanted to see. Okay, yeah, that's probably using the wrong one. That's 990. That's probably using the wrong one. Face indices. New faces indices IDX. Okay, parent first index. I feel like we probably should just start that at 0, yeah? Yeah, that's what I meant to do. And then this one starts at I and goes to I plus right child count. And what is right child count? Right child count is parent count minus I. That's correct. That is correct. That is going to be correct. That's obviously not correct enough. And what is it now? Oh, it's the same fucking line? Are you kidding me? New faces indices IDX. Okay. Okay. I wonder why we don't get it beforehand, like here, for example. Like, that would make a lot of sense. But we get it after. We get it after down here. Oh, I just didn't do the other one. Oh, my bad. Yeah, that's why you have to reuse the code, because then that shit happens. Okay, and there's something else. I'm sure that my indices is going wrong. No, it still is actually 990. Okay, well, I think I might as well just print out the indices, but... Okay. Well, I'm just going to print out the indices, but that's... Okay, well that would be the problem. There's an index of 8672508. Uh-huh. Unless we have that many faces, which technically we might, but I feel like that's a large amount, I'm not gonna lie. But I initialized them all to I. Maybe there's something fishy going on here, huh? With the swapping of the indices. Oh, wait a second. Oh, duh, because I freed it up there, you fucking moron. Like, why is this number so big? Oh, because you didn't free it. You freed it. No, you did free it. Now the laundry list of seg faults that I have to get through is killing me. Okay, so now you're mad that I have a face. Well, that's mean. 809. Okay, so now we're going out of bounds here. Just making sure that I casted everything right. Because the only thing that I can do is I can check what the index is before we index into there. I mean, let's see. Okay, see, that's the problem. That would be the problem. And what's I and what is parent faces.count? That's what I need to know. That is what I need to know. Okay, so parent faces count is 1, and that's 0, and I is 0. And so I is 0. The count is 1. Oh. J starts at parent faces count minus 1. Ah. So okay, so I'm assuming that if I do this, then we're going to run into another issue. Yes, exactly. How about no? How about if we detect that, then we just exit out, obviously. I'm wondering why that wasn't a problem before. But I mean, maybe this is just a problem with local indices, is that you get a size of 1, and then the J just fucking owns your ass. It's J minus minus. But then these should be equal, no? Wait, this is, yeah. Hold on. This is before. Oh wait, hold on a second. This is probably not even the right one. Well, now I mean, who knows which is the right one? That's kind of the problem. Wait, we know which one it was because we compiled, and GDB told us. It's 810. Ah, so it is this one. And it's deterministic, so it has to be that one. Okay. We're just gonna do it after every swap size T. Okay. So I think that just has to be it, huh? Fuck. Well, I mean, it's because it's 0 and 1, and this one there is nothing there at that index. But it says that its parent faces count -1. Okay. If J is 1, then we have to... I don't want to fucking do it though. Okay, we're done. We're so done. Oh my fucking god. Okay. We're at 1081. Okay. So immediately what I'm thinking is that oh, okay. Wait, no. But we're always going to be, as long as J is greater than 1, and J is less than or equal to 1. So there's no way that we don't have indices, because... Yeah. Because if J is less than or equal to 1, then we immediately... Oh, but J might change. Stop making noise. Okay. Why do I feel like this is... like I'm not doing this the right way. Alright, we're just gonna print out the indices. We're just gonna print out that index. Because I feel like it's just probably massive for whatever reason. Okay, now we didn't even get there, so I didn't even get to see what the... Oh. My bad. Okay, see, this is the problem, bro. This is the problem. How do we have that many? Okay. I plus right child dot count. How about this? How about this? How about this? Just go to how do we do the count? What's the what, it's parent. No, you fucking idiot. You little fucking idiot. It's parent faces count. Okay. Okay, 848. 848. No, we're not back to this again. Nah, you gotta be fucking kidding me, man. You gotta be fucking kidding me. There's something that I'm missing with the I think I've got too many variables that are doing the same thing. Okay, so this is 0, 0. Oh, we're not even supposed to be using that. I just want to see. Well, I should probably just grab this. That's what I meant to grab. Boobadoom. Okay. Okay, so it's another insane little index. Dude, I think our I and our J are just gonna go out of bounds, bro. I think that that's just what's gonna happen. If our I starts at 0 and our J Yeah, I think we might need another sorting algorithm, bro. I think that this is stupid. I think this is stupid. I think this is stupid. Okay, maybe we just simplify it because this is ridiculous. And I think our J is going out of bounds or something. Actually, we can test it. Let's just go back to that one. Let's just test what J is. When it gets fucked up, you know? Because we don't have a bound on J going to town, you know? Okay, see, so... Wait. Wait. What? There's another thing that's printing out. There's another thing. It's that. Parent faces count? Why is parent faces count that much? I think I may have fucked up, bro. I mean, this has to be where it comes from, though. No. The J going out of bounds. $847. I went to 857. Bro. Like, fucking serious, bro? Parent faces count is 0. Oh my fucking god. Oh my fucking god. Oh shit. Oh shit. Oh shit. Oh shit. That's why. That's why, because I was using size T's, and it went negative, and it went negative, and it went negative, and it went negative, and okay, okay. Okay, we're back to having really shitty triangles. Okay. But at least we're compiling now. At least we're compiling. Can I take... Well, no. No, yeah, you can. Okay, we're back to having really shitty triangles. I kind of want to try, like, to see, does it still work if we just return out immediately? Okay, it doesn't. It doesn't. It doesn't. It doesn't. It doesn't. Which is worrying for sure. For sure, for sure, for sure. Let's just try to get that working, because that should always work. That should always, always, always work. Dude, GDB is just, it just talks so much on Windows. Just shut up. Very simple. Shut up. Now another question. If I just go to parent, I'm gonna get infinite recursion if I go any further. Oh, actually, no. No, I won't. What editor? I'm using Helix. Okay, so that's what we want to see. Now the normals are, they leave a bit to be desired. I do feel like the normals are a bit funny, but that's all right. You're a bit funny. Okay, so here's a question. What if I just... Okay. Parent faces dot count. Yeah. I'm all over it. And then you go to I. Okay. Let's just try that splittage. Okay, yeah, so still incorrect. I really wonder what's going on with the normals. That's like my first question. The normals are a bit funny. We go based on the face normal, which we get new faces indices. Oh, we weren't using the points isn't the new points, is it? It's new points. Aha. Well, I did name it very aptly. I did aptly name it. And also, I'm not using... Oh, but this doesn't even matter. This literally doesn't even matter, because we're going based on what we have in it. Okay, so new points. I wonder if that changes anything. The normals should... Okay, the normals are fixed now. Absolutely. Okay, so now we have a good starting place. Also, these are going separately. These go to I, and that one goes from I to parent faces.count. So we actually have successfully done it, except for the fact that we haven't commented in any of the actual triangle clipping. So yeah, that's exactly what I was expecting from a dumb motherfucker like me. You feel me? Oh, Anna, you're still awake. That's crazy. You know what else is crazy? My ass right now. Absolutely off the fucking chain. About to punch a hole in a wall. I may be a little bit unhinged right now. Maybe a little bit unhinged. Unhinged. I'm unhinged. When I rewrote it, because the undo wasn't working, I forgot to do the +3 for indices, and I did ++. Ah, yeah, that sucks. Secondary, when walking down the tree, I was forgetting to set the min-dist and index. Now it looks much closer to ground truth with no Excel. There is artifacting. Well, I'm glad that you figured out the bug. I've kind of figured out the bug. I'm locked the fuck in right now, but... I mean, I don't really have a bug necessarily, as I think I just built something that's fucking stupid. But that's okay, you know? We can't all be like, you know, like a little genius, you know what I mean? Damn, that's really fast. That is really fast. That's excellent. That is excellent. We clip the triangles. Oh, I just had I just had an aha. Dude, that was one of the funniest things I've ever done, I think. Oh man, what the fuck was that, man? I think I figured it out. Wait a second. Yeah. Wait, I'm using the wrong one. I need some fresh air, man. Fuck. I closed the window because I thought that there was a bug in here. And then I realized that there wasn't a bug in here, and I was just tweaking out. Well, 1.57 is pretty close to the same thing, huh? That's pretty good. Why did that make... Huh? Hold on. Lock the fuck in. We need to get... Yeah. Trust me, I'm all over it. I'm all over it like jam on bread. Can we fucking get serious, bro? What are we being silly right now? Because if you want to get silly, we can get silly. Okay, locked in. Locked in, like, okay. Something is still wrong? Oh no. Oh no. Yeah, something's wrong here, let me tell you. Let me tell you. Something is a bit fishy going on here. I think my triangle clipping algorithm might be fucked. I think that's what I've decided now. I think that's what I've decided. Because any way I slice it, you know, it just comes out empty. Like my soul. Oh wait. I don't actually copy it in from new verts. Okay, I copy some in here. It is a bit laggy. I don't remember which one of these it is. I just have the same code twice. Oh, I put if did cut there. But now I don't have to because I have two things. Okay, it looks identical. Well, 10 is pretty good. 10 seems like a good middle ground, you know, in reality. You know? Hold on a second. This is supposed to be points. Oh. When in doubt, read the code. Okay, well, it's still fucked. So, go figure. Yeah. If I just do this, then it works fine. Oh, actually it doesn't. Actually it doesn't. If I do this at all, then it doesn't work. Or maybe it's the did cut equals 3 return. That's the problem. Oh wait, no, because I returned before that. Okay. So it's the clipping that's the problem. Ugh, fuck. Yeah, I'm kind of stuck. Not gonna lie. Not gonna lie. So it's one of two things. It's either how I'm clipping the triangles or it's or it's something else. I think it's how I'm clipping the triangles, not gonna lie. I have no clue how to debug it though. And I mean my plane might be wrong, like a lot of things might be wrong. I mean, on paper it looks fine, right? Yeah, 10 seconds sounds good, yeah. Yeah, I think how I'm clipping them is the problem. I want to see what the bounding boxes are, if they change at all. Oh, interesting. Whoa, interesting. Okay. Well, we may have a fucking bigger problem than I thought. Unless that's just because of the way that I'm printing it out, which it might be. Let me just try to let all triangles through. Yeah, and our BVH ends up fine. I guess. I mean, the partitioning is whatever. It's basically how it was before, with more spots that. Yeah. Yeah. Oh, also, I didn't do it. Oh, wow. Shit just gets destroyed when I do that. If parent faces count is greater than 0. Why does that break things? I need that for... Well, that's fast. What does top only mean? How is this any different than if j greater than 1? This doesn't make any sense. It's like part of it gets cut off. If I do this, then we're gonna segfault. We don't segfault? Okay, and now we didn't segfault. Huh. I guess at some level we start leaving faces behind when we can't clip them. I guess that's the reason why. Interesting. Top only taking a billion years. Is 64 by 64 just too much for an STF? I kind of feel like I'm ending with a worse result than what I fucking started with. But I guess what it comes down to is the clipping. We actually aren't clipping triangles because I can't seem to figure out how to do it. So, yeah. Here's something. Let's just, instead of giving in new verts and doing all of that fucking bullshit, let's not do new verts, because let's just not worry about recursively doing it, and let's just go in with points and faces. Let's just give it straight to clip try to plane and let it handle it internally. Oh, it is already doing it here. Oh, so it was adding it twice. Back to struggling. Oh, at higher resolutions it struggles? That sucks. And new points in subdivide try. BVH. At 1099. Hold on. Okay. The ground truth is actually worse than the accelerated one. Really? That's surprising. That is really surprising. $10.99. Sir. Oh, hold on. Well, that's good that you have something that's working then. if that's the case. Yeah, this is still fucking going crazy, huh? This function doesn't do anything else. It seems to die on right faces. Yeah, prints take a while, huh? I feel like I'm going crazy here. Fuck. I really have no clue what to do anymore. What's causing this to... that. How does the parent faces change, though? How does it change within clip triangle? Fucking Christ. Hey, what's up, Max? Do I ever use nodes? Oh, hold on a second. I think I just got it. Our nodes need to be recast as well. We can't just, yeah, our nodes need to be recast as well. Yeah, so I only do this and this when obviously I need to be doing both of them. So let's just prove it by doing a bunch of overkill casting here so that I can prove it to myself so that I can stop fucking losing my mind. Because that's just not it. Okay, thank the Lord we figured it out. Okay, so it's just a bunch of pointer shit that I don't really feel like explaining, but yeah. Okay, so we have another one at 856. If I had to guess, it's something that's either negative or out of bounds. So that one's an easy one that we can grab. Also, let's make sure that we're also following the same thing. Basically, what's happening is that we have multiple pointers that are connected to each other. So this is what happens. So 88, 89, 87. Let's take a look. We are over here. That was J. Our faces count. So this is a bit strange because J is 23987 and our I is 23988. Oh no, that's our indices I. And our I is 0. And our max is 23989. Parent faces count. Why compile using GCC? It's just what I'm more comfortable with. I looked in chat and 21 minutes ago is my baseline. Alright, peace out. I will I'll be here in case you check back in. So how are we out of bounds if we're not out of bounds? Oh, maybe it's points that's out of bounds then, not maybe it's our face indices that are out of bounds then. Because technically this indices I is underneath the faces count. So by 1. Are you able to step in? Are you talking about, in GCC, step through it? Probably. I'm just gonna see all of the face indices themselves, I guess. Oh yeah, I can. But I mean, right now it would be about the same thing as I'm about to do. All right, let me see. So yeah, that's probably the problem. Fuck, I didn't I didn't print out the fucking the thing that I actually need is the it's new points. Wait, what is it? No, it's parent vertices. That's what it is. We might actually be within bounds there, but let me take a look. It's close. It's close to being in bounds. It's not like there's some bad memory that's being problematic. Yeah, we are within bounds. That's what I was thinking. We're just really close to being out of bounds. All right, let's take a second here to see something. Let me try getting rid of all of the triangle clipping stuff again, and then see if it's that. I'm gonna assume that that's what it is. No, it's not. I'm just gonna fucking comment everything out so that I can at least see if we can, you know. That's just completely strange though. No, yeah, definitely some crazy shit is going on that I do not understand. I'm going to create a memory leak on purpose. I want to make sure that we aren't freeing this. I mean, it would have told us in GDB if we were, but okay, yeah, it isn't that. It is not that. Maybe there's some more clues that I can get as to why that's happening. You know, I got rid of this. I didn't really think anything of it, but maybe this is something to do with it. Or maybe not. I mean, now that I'm looking at it, probably not. The faces was right at the end, right? Yeah. Right on the edge. Why would that be happening now? Even when we aren't clipping the triangles. The only thing that's different is that we don't clip out here. Oh, wait a second. No, yeah, we pass in the same thing. So why? Maybe if I just do one plane. If I just do one plane, it's fine. But 3 planes, it's not fine. You know, normally I would think like, okay, well, it's a problem with, with a double pointer, right? Like I'm thinking like, okay, well, when we allocate, you know, the points vector inside, when we reallocate it, then it touches something outside, but that doesn't make sense in this scenario because everything is double pointered, because it's pointers of structs that have the buffers. So it's all pointers all the way down. So, you know, there's something else that I'm not thinking of. Unless it's just too many. Maybe we just simply run out of memory. I doubt that that's the case because we would probably get a different error. But this is like a lot of fucking memory at the end of the day. So that is possible. We can probably test that by trying to limit the depth and then seeing what it's like. But yeah. Just like go parent faces count less than 12. Really? If I go 120, then it's just gonna be one bounty box. We'd also do depth itself. Alright, let's do depth itself. I don't have depth in here. Whoops. Okay. Okay, that just... Oh, I meant to do depth greater than... I did it the backwards way. No, yeah, this still... I mean, 29. Maybe not. I thought for a second that maybe it's about these things going out of scope, but that shouldn't matter because we're copying them by value into here. So yeah, it can't be that. I'm gonna see the capacity as well. I doubt it's that. I assume it's the faces actually. When do I cast? Yeah, I cast at a fine time. Alright, let's see the capacity as well. Index into a1 with the faces count of that. The J of this. 29 nodes entered. Oh my gosh, I think we're just super laggy. I wonder how many triangles it is. Can I check that? I need to see, oh, actually, you literally use, $52,000 triangles. Or points, actually. So really not bad at all. Really not bad. So I doubt that it's memory. I really do doubt it. Definitely tell us. Like, just literally do it 3 times. This is stupid, but yeah, just like literally, let's just literally wrap it 3 times. And now you run into issues. See, this is the problem. Are my vector implementations just dangerously bad? Or do I set up these with the wrong type size? When I make new ones, I set them to vec3 and mesh face, which is what they are supposed to be. So I don't think so. I want to try expanding by 1 every time. And then just see if that works. It doesn't. Okay, I'm just going to manually expand the buffers. What does it have to do with this? I think I'm running into a rookie mistake. I think my vector implementation is bad. Just out of curiosity. All right, I mean, down here I don't change anything, right? No. I feel like I'm going crazy. What? I cast both independently both times. Huh. I mean, I don't think my vector implementation is wrong. I might have to do some calculation here to see. To see if we're getting the correct in versus the correct out leading up to the crash. In 20, 4 times 3 is 12, so 72. Ah, fuck. I wonder if this pointer arithmetic is scary wrong. I mean, it's not wrong because it's never been wrong. But what if we just don't do that, and instead we just go, we just cast the buffer afterwards, and then just try that. Because I don't think that we're allocating to the wrong size. No, still, huh? I mean, this is pretty sketchy what I'm doing too. Like, this is like not like the most like safe code that I'm writing here. But I mean, the only thing that would make sense is that somehow I would assume that we would crash though when we're. The problem is this points count thing, I think. Rather than how we're indexing into it. Because we could just, oh, wait, hold on a second. That shouldn't matter though. That should not matter. What matters is this points count and the fact that points just isn't sized properly. I'm almost interested to see like what happens if I just times 2 the whole goddamn thing. No, yeah, nothing. I might be creating more bugs here. Yeah, definitely. Yeah, I'm just gonna cause more problems for myself. But I want to see like if the capacity is actually the capacity. I mean, I don't know. It's probably something else. I might just be corrupting the heap somewhere else. And then it just shows up here. Yeah, I'm surprised that there's no, like, I don't know. Maybe I should try GDB again. Surprised that I don't know. It's just a seg fault. Like, let's print out the pointers, I guess. Let's print out the... Alright, I'm gonna head out soon, I think. I'm hungry. Or I might eat here. Dude. Okay, this is ridiculous. 8:33. Oh my god, it was at a different one? You gotta be fucking kidding me. You're fucking being funny that you want me to do this. I should have just put it outside of the while loop. It's not like any of this would change, really. I don't know. I think we're working with such a large amount of triangles at this point that it's probably something with large numbers at this point. That's, yeah. So I mean, and it's supposed to be points, right? Hold on a second. Hold on a second. Hold on a second. Hold on a second. Are you fucking kidding me? Are you fucking serious? No way. Wait. Oh my god, are you fucking serious? I'm so excited that I can't even type. Dude, it's like I'm a kid on Christmas right now. I left the fucking printouts in. Wait, how was I not seg faulting before though? I just had like literally 0 triangles. Holy fucking shit, we're in business. We have 1 frames per second because we're drawing all of the triangles themselves, but we're in fucking business. Okay, of course we did just add the same triangle 4 times, which is not what you're supposed to do. We just wanted to clip try against plane, and now this whole thing is commented out. The reason why it's so laggy though. Okay, so try 0. Try 0 cannot be good. Are you seriously telling me that we're getting 3 splits every time? That seems to be like what you're telling me. That's ridiculous if that's what you're telling me. fuck. Well, I guess we're not done. I don't know why we're in this file, by the way. I didn't press that. Did I comment something out when I was working on that that's important for us to have now that I did for safety before? I don't think so. How does clip try against plane not give us triangles, though? Oh my god. Man, I thought that we were fucking over. I thought that it was finished. Oh wait, hold on a second. Oh, I was giving in the wrong thing. I meant to, yeah, I had the wrong fucking thing in here. Okay, 72. 72. 72. I wish that I could do triangles with outlines. I don't know how to manufacture that. Just so that I could see, I don't know. Just to see how they clip. That would be really cool to see if they clip properly. Oh, I didn't put against 6. 6 is actually, you know, how it's supposed to go. Holy fucking shit. That's 4 million triangles that we're adding to a buffer every fucking frame. Okay, chill out. Chill out. Okay, can we set up the system again that we had with this so that we can actually, you know, with did cut and didn't cut and all that shit. If did cut equals 0, we want to add it and then return. Okay, let's figure out how to reconfigure this. And then this and then this. Okay, let's give that a shot. And it's completely fucking fried. Well, oh wait, hold on. Yeah, you're supposed to do that. Yeah. Yeah, I don't know. I don't know. Like, if we just do the clip triangles, then we end up with this, which is just nothing. Yeah, I don't know. Oh man, it sucks that I didn't get this done today. I kind of want to keep working on it, but I do need to take a break to eat. At this point, I'm just... Oh wait, this is... Oh wait, but it doesn't matter because I'm not actually doing any of the cuts inside. Oh, I do actually do the cuts inside. But we iterate on new verts and new faces later. The problem with perform clips, actually, is that we go based on faces count, but we don't actually add it to it. So you actually have to add this to it when you go in. I didn't actually do that, but you actually need to do that now. Then you at least get something. But it's only 78 triangles. Oh gosh. Basically what this is supposed to do is it's just supposed to be a test to see if we need to clip. And then we do this stuff. But yeah, it obviously isn't clipping properly, or the indices aren't working. The whole point though is to basically take the new stuff and then just append it onto the end of the main buffer, right? So we do like all of our cutting work internally and then we put it onto the other buffer. But it looks like this doesn't work, so... Yeah, I may have to like step through it. Yeah, I mean, this should work, though. I kind of want to, like, wonder if getting rid of these returns... Well, the problem is that also new verts and new faces needs to start from 0. Oh wait, what the fuck? Holy shit. Oh, okay. The normals are fucked, but it looks like all the triangles are here. Except for maybe that one. Why are the normals bad? Oh, because I don't actually set the normals in the beginning. Holy shit, wait a second. It's 228 triangles. Let's see if we can render them so that we can see the actual let's get rid of the bounding box. Let's see if we can see the... Huh. Well, to be honest, this just looks like fucking normal. Unless it's... unless they're cut inside. Which they might, to be fair. We could try GL lines and then doing the pattern where we just do 0 at the end, 0 1 1 2, and then 2 0. It says that there's 456 tries, but that doesn't look like 456 tries. There should be tiny triangles, I don't know. Faces, node vertices. Maybe let's take off the restriction for if it's, I mean, this is probably gonna crash. Yeah. I don't know. I think I'm just gonna set it back to triangles. I'm going to last min try of 1. Take, you're serious? That's crazy. That's really low. What? That's insane. That's very, very fast, huh? I mean, that just sounds fast to me. I mean, I don't really know how fast it is, but that does sound crazy fast. I'm gonna steal this. Okay, I really need to go eat something because I'm about to explode, to be honest. We're not gonna go by hole count. We want to go by the face. Node faces dot count. Go k node faces dot count. Okay, and then use that normal just to visualize it, that the triangles are separate. Same for dragon isn't that big. I mean, that's the serpent that we saw earlier, right? I mean, it seems pretty. I mean, it really doesn't seem that different at all. I'm not gonna lie. But the triangles are definitely clipped. The triangles are 100% clipped. Because we know that there's more triangles now than there was before. We take the depth off of it. 228. Tries, really. Well, I mean, I think it's doing it. I don't really know if it is. I could force it to split more, I guess. And can split. Yeah, being frozen tells me on anything complex it takes down. 1 is too small. Yeah. Well, I mean, I thought that that dragon mat had a lot of stuff in it, but I guess not. Yeah, I don't think it's splitting right. Also, in the middle, there's just empty space now. Yeah, it seems to just cap out at 228 tries. Yeah, I'll have to keep giving this a shot. I'm not really sure, like, if the clipping method is correct or not. I'm gonna have to keep giving it a try. I have a feeling that it's somewhat working, but I just want to check out the tries right now with no clipping. So 228 tries without clipping. So it's exactly the same. So it's not working. I thought it was, but I guess it's not. Yeah, I'm not sure. At least to me, it's not worth enforcing a lower min try if the blast gen. Yeah. Yeah, probably not worth it. Yeah, probably not. Probably not worth it. If you do this, then yeah. Yeah, I don't know. I'm gonna have to keep trying on this. It's kind of a bummer that what is P? P is the point. Is the try. Yeah. If did clip. I doubt we're gonna get any printouts. We did actually. We get a few clips. But I actually, you know what? I want to see if this is this. Caching still, yeah, caching is probably going to be the best thing to do ever. Yeah, so I'm not actually getting anything. Wait, hold on a second. I was supposed to be doing phase points K. Oh, shit. Yeah, and then we crash. And what does GDB say? Just to see. It's at 517, which is Seg fault at 517. Yeah, I'll have to see. I'm assuming that we have like some infinite recursion or something. I don't know. Oh, actually, it's probably that we need to recast this every single time we go around because we're touching it every single time. Shut up. Slightly slower. The cache isn't cache supposed to be like insanely fast though? Oh yeah, we're clipping, baby. We're fucking clipping. We are clipping so much that I can't even get past. Okay, yeah, this might be a bit ridiculous. Oh, it's an infinite loop. It's an infinite loop. It's an infinite loop. We can fix it right now by doing that. Okay, it might still be an infinite loop. It might still be an infinite loop. Okay, I'm going to peace out here in a second. Buffer without size? Oh. It looped that many times. It looped to the point where my computer got that mad. Wow, this is taking fucking forever. Huh. Okay. What if we have a safety of 2? Huh. Okay, well, yeah. Yeah, so this is a problem. I think it's a problem because we have an infinite loop in here, because this goes through and then we have a new faces count. Oh. Hold on. Alright, let's try it one more time before I get off. Holy shit, it's like watching my chess engine go. Yeah, this is intense. Okay. Yeah, let's just do a safety of like 2. I have a feeling it's cutting the same triangles twice. Alright, I'm gonna peace out. I'm getting hungry, so thanks for hanging out. I probably will work on this more tonight. But yeah. Alright. See ya.